first section we are discussing. We are talking about SAP HANA Foundation. So in the previous session, we talked about the evolution of SAP product. We understood how SAP started off its products, what were its plus points, what were its challenges. There's a question from Munib. Let me quickly look through that. Munib is saying he's having access issue to the blog. So I'll have the coordinator make sure everything is taken care of. Munib, don't worry about it. Okay, we'll make sure that everybody has the right kind of access. All right. Okay. So we talked about SAP evolution. I'm hoping that this is the first session, Samshul. So what we did is in the previous session, it was more of a demo introduction where we talked about how did SAP's product evolve, right? So that's how we have done. We have not gone into SAP HANA at all. So today is the first class where we are going into the details of what SAP HANA is, why SAP HANA. We are going to be discussing that topic today. All right. So in SAP evolution, excellent. All right, thank you. So I understand that there are a few new candidates who have joined the session. All we have done is we have covered one other session, which was also like an introduction session. So as soon as we complete today's session, right, please also take a look at that. Whatever we are talking today is going to be independent of what we talked yesterday. So you will not be missing any information. All right. So essentially what I said was in the previous session, we talked about what are the different types of products that SAP has in the market, right? That's all we talked about. And we gave an understanding to everybody. And today what we are going to do is, now that we have understood SAP evolution, we are going to go and understand why SAP company came up with a product called as SAP HANA. Is there a specific reason why SAP came up with this product? So we need to understand this question because this will give you a lot of information about what is the underlying technology that is being used by SAP HANA, which is making it so powerful. So that's what we are going to be discussing today. All right. So before I get started, any question on the SAP evolution? We talked about the information in the previous session. Is there any question that anybody wants to ask? If you want, please go ahead and type it in. Again, it was very general topic, just for the benefit of those who have joined today, right? Samshul and few other people. The quick 1 minute information about what we talked in our previous session. SAP company started their products. The company was started in 1972. SAP created a product called as SAP ERP. It's nothing but enterprise resource planning solution. It's a solution that is used by company for integrating data between multiple departments, from your finance team, from your marketing team, from your human resource team. How do you bring data and integrate the information, pass it on from one team to the other and efficiently utilize? Once this product was created, we saw that this product was mainly used for operational reporting. When I say operational reporting, day-to-day information. How much did I sell today? How much did I buy today? Day-to-day information was collected from this particular system. In the 1970s and 1980s timeframe, most companies were only interested in knowing how I was doing today, what should I buy for tomorrow, and things like that. When we moved on into the 1990s, this is from 1970s to early 1990s, this was predominantly the market capability. When we moved on to the 1980s, we went into the globalization era. So they said, it is no longer just sufficient I look at what I am doing. I am required to look at information across the globe because my competitor could be sitting anywhere. If I am in US, my competitor could be in China, could be in India, could be around the world, anywhere, right? So my market portfolio has increased significantly now. My footprint has increased significantly. So I also need to evolve my product to a bigger portfolio. So they said, it's not just enough for me to do operational reporting. I need to be able to do analytical reporting. I need to be able to predict my data. I need to be able to look at a trend. I need to be able to look at forecasting information. In order to do analytical reporting, SAP did not have any solution. So during the 1990s, SAP came out with 16 different solutions. 16 different products were introduced to the market. These products were called as My SAP Business Suite. The general name for all these 16 products together was referred to as My SAP Business Suite. Some of the main products were SAP BW, Business Warehouse, SAP SRM, SAP CRM, and so on and so forth. So many different products were created. The main intention was SAP BW was created as a data warehousing solution that will help you do all your analytical reporting. Then what happened? So I was able to move from operational to analytical reporting, but company did not have a great reporting tool to satisfy the presentation layer. So in the 2000s, around 2005, 2006, SAP went and bought a product called as Business Object. There is a reporting tool called Business Objects. They went and bought that company. So they completed their portfolio. They are able to do operational reporting with their ERP system. They are able to do analytical reporting with their 16 tools that they built, main product being your SAP Business Warehouse. And then they finally bought this product called as SAP Business Object, which contains a list of reporting tools. For example, reporting tools like Web Intelligence, Design Studio. I'm just naming a few of them. There are quite a few. SAP Lumira and things like that. So a lot of reporting tools were made available by buying this company called SAP Business Object. Now, if you take a look at any SAP product, we have seen that an SAP product, we talked about it briefly in the previous session. It's a 3-tier architecture system. What I mean by that is the system, whenever I say I'm working on an SAP system, you should think that there are 3 layers to an SAP system. The first layer is always your database. It makes logical sense, right? If I am bringing data into a system, into an SAP system, that data needs to be sitting in some kind of a database. Then this database to interact, it needs a software layer. This is where your SAP product comes into play. Could be SAP BW, could be ERP system, could be SRM, anything, any SAP application. Think of it as your software. The software has to reside in an application layer. This is your database layer. So we'll call this as the first tier of your architecture. This is the second layer of your architecture. And if this is the system, I will need some kind of tool to access this system, right? So they are typically called as client. You will need a client. So let's say, for example, just to give you a perspective, right? If you want to access your Gmail account, or you want to use your Yahoo account or Hotmail account or whatever email account you have, are you directly going into Google's headquarters in California and checking your email? No, right? You use a tool. So the Gmail server could be sitting somewhere in the world. We don't know where it could be sitting, right? How are we accessing it? We are accessing it through a client tool. What is the client tool that we are using? In this example, we are using a web browser to connect to the Gmail server. Does that make sense? Is everybody comfortable with the concept of client now? Client is nothing but a way or a tool that helps you access information sitting in a server. So in this case, the example of Gmail server, if you want to talk to a Gmail server and read your email, you will connect through a web browser. You can choose any of your web browser. The client could be an Internet Explorer. It could be a Chrome browser, whatever you choose. You're using the Chrome browser as a tool to look at your information that's sitting inside your Gmail server. Does that make sense? So that is exactly how an SAP system also works. Think of this as your SAP system. If you want to talk to your SAP system, you need a client. This is how SAP is architecture, right? So let's understand. So given this information, now that we understand this, let's go a little more detail into why SAP HANA. We'll understand in detail why we would need a product like SAP HANA. So before I get to that, right, I forgot to, the reason I was talking about this point is, now that we understand any SAP system is going to contain a client layer, that's what you will use to connect to the system. There will be an application layer. Here is where your SAP product will reside, your SAP software, whatever the software will be, ERP, SRM, so on and so forth, whatever your product is, that sits in this particular layer. In order to support the data incoming into this application layer, you're going to contain a database layer. So till about 2000s, later part of 2000s, SAP said, this is my proprietary layer. This is what I am selling to the market. I'm selling you a product called BW. I'm selling you a product called ERP. I'm selling you a product called SRM. You as a company, the buying company, you can go and pick and choose whatever database you want to support my application layer. You can go get Oracle database. You can go get SQL Server database. You can go get IBM DB2. Whatever database you want, you can go and get it from the individual database company. In order to support this application layer, you can go and choose this. This was the market strategy till about 2008, 2009. What is the biggest disadvantage with this? The client is an SAP client. This is SAP owned. This is SAP owned, but this is third-party vendor. I have, as an SAP company, I had no control over this database layer. In my 3-tier architecture, I only had control over 2 layers, and the third layer, my database layer, I had absolutely no control. So that brings down the market strategy for SAP, right? So SAP said, now that in my evolution, if you look back into my evolution, I have the great ERP solution. I have a great set of analytical solution. I also now have a good set of reporting tools. The only missing piece that I cannot control at this point is I do not have a database of my own. That is how SAP HANA came into the market. This is a layman explanation, right? I'm giving you like a general discussion. I'm telling you why SAP HANA came into the market, but there is more underlying information to it as to why we went into SAP HANA. That's what we are going to look into. Is this concept clear for everyone by a show of yes or no till this point? This is like a 50,000 feet information of why SAP HANA came into the market. Because SAP did not have its own database product, they said, let's come up with a solution called SAP HANA, and that became their database product. But there's more to it than what we are seeing in the screen now. Let's take a look at it. If you were to broadly classify SAP's product, though we have seen so many different products within SAP, it can be broadly categorized into 2 different major types of SAP product. One product, your SAP ERP system, which is the nuts and bolts of SAP product, is called an OLTP system, which is online transaction processing system. Your transaction systems, anytime this is your transaction system, is referred to as OLTP. That's the normal naming convention given to any transactional system. On the other hand, you also have analytical systems in your organization. So for example, if you take SAP BW, It is not a transactional system. And I'll also give you an understanding of the difference between a transactional and an analytical system, right? This system is referred to as OLAP system, online analytical processing system. A quick understanding of the difference between these two systems, right? A system is called transaction as the name implies, right? So let's say, for example, you go to a store like Walmart. You go to a store and you go and purchase some product. So what you do, you go to a cashier. He or she may be sitting on a point of sale system. They will ring your sale and a transaction is happening. A transaction takes place. It says customer A bought a product called B for $20. A transaction gets entered in the system. So this point of sale system sends the information, all the transaction that has been captured has to be stored somewhere, right? In your organization. This data will come into your SAP ERP system. As soon as a transaction takes place in your organization, in this case, if you take the example of Walmart, when a transaction takes place, when you buy the product, that transaction information comes to your SAP ERP application layer. Can the data reside in an application layer? No, right? The system will send it down to the underlying database. Let's say if it's a SQL Server or an Oracle database. So the idea of a OLTP system, so this system is referred to as OLTP system. The OLTP system's main intention is to capture all the incoming transaction and save them in your database. That is the main goal. So writing your transaction, if I want to generalize it, writing or saving transactions in your ERP system, in this case, is called as the OLTP solution. Now, we understand that this system is mainly kept for capturing whatever transaction is coming into the system. Would everybody agree? My main goal of this ERP system is to wait and capture all the transactions that's coming into me. But we also mentioned this ERP solution was responsible for operational reporting. What do I mean by that? I'm saying my main focus of this SAP ERP system is to be continuously looking for incoming transaction. Whenever the transaction comes, take that transaction and push it into the database and keep it safe. That is my predominant activity that is required from me as an OLTP system. But as a secondary need, the company will say, I'll have a set of business users who will come and say, hey, I want to look at this data and understand how much products have been sold, how much revenue have I made today, how much expenses have I incurred today. I want to know all that information. So what's going to happen? A different set of users are going to hit this system to read data from that database. So transactions are being written. After the transaction is saved in the database, I am trying to read this data. So think of this two-way traffic as your highway, right? In your highway, if you think that there is only one road, and there has to be two-way traffic that has to go in that same road. What's going to happen? There is going to be a contention, right? There is going to be a traffic jam. There is going to be information lock, or in this case, in the highway scenario, cars are either going to collide or they're going to cause a traffic jam, and there's going to be a humongous wait for the traffic to move either ways. So what they said, after looking this causes resource contention, because I do not have enough bandwidth. If all the bandwidth, if think of it as a pipeline, right? In the pipeline, if I have only 10 diameters, 10-mile diameter or whatever you can think about, that is all the gas or pipe water that can flow into the pipeline. I cannot feed any more into that pipeline. It will get clogged, right? So the total resources I have is now being shared by the read capability and the write capability. Which one takes precedent? Can anybody tell me? In my ERP solution, is writing the transaction into the system more critical or reading the data from that system is critical? Can anybody help me out? Which do you think is more? So Shrikant and everybody, Manoj is saying, write is the, because if I do not save my transaction, there is nothing to read. Would everybody agree? So in an OLTP solution, writing takes always the precedence. So what happened? Imagine if this is a highway. If there are 5 lanes in the highway, they will normally allocate 4 lanes to the write capability, and they will only allocate 1 for read capacity. So maximizing your resources for write ability and keeping very little for read ability. That was the intention of an OLTP system. But now, can I go and tell my business users, though writing is very critical for me, if I write all the data I get in the world into the database, but if I don't give anybody ability to read that information, that also defeats the purpose. Would everybody agree? So, but I know that though reading is very important for my organization, I cannot let my company read from my OLTP system. If I let them read data from my OLTP system, I'm going to cause resource contention. But I also have to give my business users the read ability so they can start doing reporting functionality on the system. So when this issue came into the market, SAP said, I understand the predicament we are in. The SAP ERP system, which is our OLTP, I'll classify it as it has a client layer, it has an app layer, and it has the DB database layer. We are saying this system is completely focused on bringing in transaction. But I also want to satisfy my business organization by giving them ability to do reporting on top of this. To satisfy this requirement, they said, hey, let's not touch this system. Let's keep this transaction OLTP system, as the name suggests, just for holding transactions. So we will continue to get the data and we will keep storing that information here. Now we will create one more SAP application, and that SAP application is called BW. Again, it is a 3-layer system, right? Because it's an SAP system. It will have a client, it will have an app layer. App layer is where your BW software resides. And it will be supported, of course, by a database layer. So the company started creating one more system. And they said, whatever data is residing in this OLTP database, I will push it into my BW system. At leisure time, during maybe night time when there is no much traffic coming into my OLTP system, I'll find a quiet time. I'll push all the data that I've got. I will send it into this database layer. Now, is this an active transaction system? Whatever transaction is coming into my system, into my OLTP, is that being captured in my BW right away? No, right? Once in a day, or maybe once or twice in a day, I periodically schedule the data to move from my OLTP system to the BW system. What is the intention of this BW system? Now the data here is residing in the BW system. I'm giving full authority to my business users to go and read whatever they want to read from this system and use it for reporting functionality. So this BW system was built exclusively for reporting capability. In order for users to do reporting, they don't have to go disturb the transactional system. They can do all their analytical reporting and in the SAP BW system. So the system that is used for doing reporting are referred to as OLAP system. Is everybody comfortable with the difference between an OLTP system and an OLAP system? Why you need an OLTP and why you need an OLAP functionality? OLTP keeps maintaining your transaction. A copy of that data goes into an analytical OLAP system, and that is where you will do your reporting. Now, this is all great. SAP said, we are very happy with coming up with a solution like this, so I'm solved my problem. But once you got this data here, in the 1990s and early 2000, my worry was, how can I beautifully do the reporting on top of it? How can I get information? But what happened? Worry about database was not a big concern. In the 1990s and 2000s, data was maximum companies were getting was typically a terabyte or something like that. Even terabyte was very uncommon in those days. Not that much of volume of data was being typically stored in your database. But in the 2000s, with data exploding, what happened? Companies got exponential growth in their data setup. So what happened? What used to be several thousand transactions per day became several million transactions per day and even several billion transactions. So the OLTP system kept storing the billions and billions of records that came into the system. And these billions of records were pushed into the BW system. And that was used for your reporting capability. Now, if I ran a report on a table that contained, let's say, several thousand records, maybe 10,000, 20,000, the performance of the reporting will be relatively faster. Would everybody agree? It's only small amount of data. I can just quickly run a report and I should be able to get the data. But with the data growth increasing exponentially, now I'm storing millions and even billions of records. What would happen to my reporting performance? If I did nothing to my OLAP layer and just expected that even if the increase in data goes from thousands to billions and millions, will my reporting performance remain the same or will it take a hit? Will my reporting become extremely slower or will it continue to be fast? What the normal expectation is that your performance will significantly go down. Would everybody agree? So knowing that the reporting can no longer be satisfied just as is, they said, I have to do something to increase the performance on my database. I always give you the analogy of a car, right? If you have a Ferrari car, a body of a Ferrari car, but the engine is of a 1990 Toyota Camry that's placed inside it, what is the output you're going to get from that car? Though the outside body looks great, if it is supported by an engine which is very old and very non-performance oriented, it's going to give a very, very slow performance for you, right? Similarly, if you have a great analytical tool, the application layer is phenomenal. It can do a lot of number crunching. It can do a lot of great analytical reporting for you. But if the underlying database could not support the large volume of data that is being collected, it's not going to make sense. So as the first step, what SAP said is, so here is my OLTP data, my SAP ERP system. I'm sending data from here to my SAP BW system, SAP BW, which is OLAP. Think I have the underlying database here. This also has its underlying database. Now I'm saying, because I have got a large volume of information getting dumped into my database, I'm not able to perform extremely fast reporting. If my report takes 10 hours or 12 hours to run, is any of, in the current market, is anybody going to be interested in looking at that report? No, right? So what SAP initial step, what they did is, they said they created a fast performing engine. A set of PhD students working for SAP went and created a new product. It was called Trex engine. They created, just like your Google engine, right? The moment you go into Google and you do a search and hit on the enter, press enter button, millions and millions of records comes out instantaneously. So there has to be some kind of an algorithm or an engine behind the scene, which is processing the data. Imagine the volume of data that Google server could potentially contain, right? So churning that data and bringing data in an extremely fast manner would need that there has to be some kind of an engine behind the scene, which is helping it churn that data. Taking that same concept, SAP came up with an engine to help speed the reporting performance on your OLAP system. This system was created to exclusively support your BW system. So the name they came for this engine was called BWA, Business Warehouse Accelerator. It's an accelerator. It basically is giving you a turbo boost to the data that you have. So essentially what they did was they created this BWA system separately. This is all in memory. After the data has come into your BW system, is sitting in your database, a copy of that database is sent once more into your BWA system. And the report is given a choice. When a report is run by a user, it can go to the BW layer to get the data, or it can go to a BW accelerator to get the data. Because the data is stored in memory inside your BWA system, the data return capacity is extremely fast. But if you go to directly the BW layer and get the data, it's going to be processed only by the speed of the underlying database. So the performance is going to be much, much slower. So to bring this information home to everybody, right, just to give you a perspective of what we are talking. Take your own case of laptop or your desktop. You bought a computer brand new, and this is the very first time you open a browser in your computer or your laptop, and let's say you type in gmail.com. You go into your browser, whatever browser you choose, you're typing in gmail.com and you hit enter. The first time you use your computer, what the system is going to do is, it will take the IP address associated with this particular gmail.com. It will go search for the corresponding domain name server. It will go identify what is the corresponding domain name server for that Gmail system. Go to Gmail, identify the data that you're looking for. It will go to the server, physical server of Gmail, bring all the information back and display it to you on your laptop or your desktop. So the first time you do this, the time taken to process all this information is going to be significantly larger. Though now you will not see the difference. Typical approach is this process, converting into your IP address, moving it into your domain name server, searching your Gmail server, bringing back your information. It all takes time. But after you have done this the first time, what typically happens is this entire information is stored in your browser cache. Your browser contains a cache, right? So what will happen? It will store this information in your cache. The next time you go and say gmail.com, it will immediately not go through this rigorous process of finding what it is. Rather, it will just go to the cache and bring it right away. So the analogy I'm trying to give here is cache is nothing but your memory, your RAM in your system. Anything that is stored in your RAM can be accessed much fast because it's all in memory. But if you did not choose the memory option, but you went the traditional route, it's going to take a significantly larger step. Does that make sense for everybody? That is the same logic we are applying to the BW system. If you directly went and hit a BW system for reporting, it will take the traditional route, go into the database, try to figure out what the data you're asking for, bring back the data and push it into the reporting layer. But if you had stored all that information already in your BWA system, which is your in-memory system, the retrieval of that data becomes extremely faster. There's a question from Samshul. Is the size of BW underlying DB and B? Typically, that's a very good question, right? That's a very good question, Samshul. So I'm getting exactly that's where I'm getting. So before I answer that, is everybody clear with the concept of what is the difference between directly hitting a database and directly hitting a in-memory system to fetch your data? Because the data is sitting in memory, the data retrieval becomes extremely faster. By a show of yes or no, could you agree or disagree with me? So that I know where we are, everybody, right? I want to make sure that we are all in the same page. Does that concept make sense to everyone? You have your SAP BW system. You have your traditional database that's supporting it. You also have an additional BWA, which is an in-memory system that's available. So you have now the choice of when you run a report, you can either go the traditional route or you can directly bypass everything and get the data from your BWA system. Going back to Samshul's question, this is a great performing system now. As soon as this came into the market, everybody who was using SAP BW became so happy. Now that I have a better way to run my reports faster. But can anybody tell me what could be the potential drawback with this approach? I think Srikanth already answered the question. Though it is good, it is giving me a great performance boost. You will see that there is data duplicate or redundancy. Would everybody agree? I'm storing the data once in my traditional database. And in order to improve the performance, let's say I have 10 terabytes of data here. I will have to push all the 10 terabytes data into this another system. So I am maintaining the data 2 times to get performance improvement in my reporting. Does that make sense? So this is a big concern, right? I'm going to be spending a lot of money to buy this product. So one disadvantage of this product is data redundancy. Every time I need a data to be much faster, I have to push it into my BWA in-memory system. The second thing is, think about the maintenance nightmare. I have to do maintenance on my database system. I have to now do maintenance on my BWA system. What do I mean by maintenance? I have to upgrade the database. I have to upgrade the BWA system. I have to maintain patches on the system. I have to maintain patches on this system. I can have issues in this system. I can have issues in this system. So now my problems have become double fold. So these, though BWA was giving a greater performance, it also came with a baggage that I have to now maintain data redundancy and huge amount of maintenance and support for both the systems. So this was the significant challenge faced by any organization that was running SAP BW. So SAP started looking further into this, and they said, everybody is complaining that this is, though giving a great performance, I have to do this data redundancy and maintenance. I am disadvantaged because I am still waiting on somebody's database to perform. Because of that, I have to keep all this redundant copy of this data. Why not I go and create my own database? So when SAP thought about this, they said, let's not start something from scratch. I have created a great product called BWA, whose underlying technology is called Trex engine. It is using in-memory capability to store and retrieve the data. Why not I take this concept big and see if I can do something about it, right? That is how SAP took this concept of BWA and converted it into a full-blown database. That is how we came up with this, or SAP came up with this product called as SAP HANA. SAP HANA is a database. Imagine your entire database is now sitting in memory. You don't have a traditional database and then pushing data into your HANA database in memory. Both of them are replaced. You can say your SAP BW is now sitting on top of a database which is called as SAP HANA. Just that this database, entire database is now sitting in memory. Now imagine as the data comes into this HANA in-memory database, what happens? My performance is extremely already great because it's an in-memory tool and there is no redundancy of information. So Manoj has a question. At this point, was it a DB performance issue or the design issue? It was a combination of both, right, Manoj? Because I was relying on another company's database performance. Because this is a proprietary tool of some other company like IBM or SQL Server or Oracle, I could not go and meddle with that database performance. I am limited by what I have been given, correct? I could only play with, as an SAP company, I could only play with my in-memory system I had built. So they took the concept of a traditional database and took whatever they learned from this in-memory tool called BWA, and they created a combination of these two tools together. And that product is called as the HANA product. Does that make sense? So that is exactly how SAP came up with this product called as SAP HANA. So think of it, SAP HANA, when it came into the market, it had multiple reasons as to why it came to the market. One, plain, simple and straightforward. SAP wanted to always get into the database market. Though they were controlling the two tiers in the architecture, the client layer and the application layer, they never had control over the third layer, which is the database layer. Now, by bringing this SAP HANA product, they are directly competing with the great products like Oracle, SQL Server, IBM DB2, so on and so forth. But that is not the only thing, right? The other capabilities, they are also solving business users' problem, organizations' problem. Instead of maintaining two different systems to get a better performance on your reporting, if you went with a database that is already completely sitting in memory, you are getting better performance naturally. So that was the bigger idea or the biggest sell for SAP HANA as a product. But let me also give you the realistic picture of what happened with SAP HANA. So SAP HANA came into the market in late 2010, toward November of 2010 is when the product came into the market. So if you look at any of the Fortune 500 companies or even the Fortune 1000 companies, 90 to 95% of those companies use SAP product, right? So typically what they would have an SAP ERP solution, which is being supported by some database management system, let's say SQL or Oracle in the traditional world. They had their OLTP layer. Because they could not do reporting on it, what they would have done, they would have pushed the data into an OLAP layer, SAP BW. also being supported by some traditional database like Oracle or SQL Server. This is the traditional route that any organization would have taken. Now, they probably have to increase their performance. They bought BWA and they are going through the pain of maintaining that system, but they're still getting some performance intense operation. They are getting that performance boost. Now, this being the scenario, SAP went and created this new product called SAP HANA, which is not a tested product, though it is claiming that it's a great database because it's all in memory. I have to sell this product in the market, right? SAP has a point to sell this product. Can I go and tell organizations which have been running their SAP systems for decades together, hey, I've come up with a new product called SAP HANA. Do one thing, go and just scrap your underlying database and replace it with my new product called SAP HANA. Do you think this would have sold? If I went to a company which has been running their databases with Oracle or SQL Server for like 3 or 4 decades together, and I say that, hey, I've come up with a great product, just why don't you replace your existing database and start using mine? No company would have felt confident, right? Because this is a new product in the market. We don't know what its pitfalls are. We don't know what its issues could be. So no company would have taken the decision to go about replacing their existing databases with SAP HANA. True matter of fact, right? So how did SAP HANA get into the market? So SAP HANA took a very strategic move. They said, I know nobody is going to replace their underlying database automatically into SAP HANA. To give you a flavor of the credibility of this system called SAP HANA, they went with a concept called as the first type of implementation of SAP HANA was called sidecar implementation. Just to give the companies a feel of what SAP HANA can do, SAP introduced the concept of SAP HANA as a very low profile. They said, you could be having an OLTP system like SAP ERP. It is running against a traditional database layer. Do not interfere or touch this system. Let it run as is. The transaction will continue to come into the system. The data will keep going into this database layer. To show proof that SAP HANA is capable, they said this ERP solution can contain several modules, right? We talked about finance modules. It can contain logistics modules. It can contain human resource management system. And within finance, it can contain several classifications like accounts payable, accounts receivable, general ledger, sales and distribution, payroll and administration, so on and so forth. There are so many subsections of information that is stored in the ERP system. They said, take one critical application in your ERP system where you're seeing the pain today. Let's say your users are wanting to do a lot of reporting on accounts payable data. But today, the traditional route is I send my accounts payable information into my BW system, supported by some kind of a database. And I either choose to use a BWA system or I traditionally run report on top of it. And we know how the performance is. I am not asking the company to alter anything. I am only requesting that identify one small section of your data. And to test the power of SAP HANA, we will stand a separate SAP HANA database for you. We will come and install this HANA database in your organization. Just identify that accounts payable data and send it to the HANA database. And then try running reporting on top of this system. So the name is called sidecar because it's not a primary database. It is a secondary database that you are using in your organization, just to prove the point that it is a powerful system. In the year 2010 and 2011, The only type of SAP HANA implementation that was happening was sidecar implementation. Adding it as a secondary database in your system so that you can send some data into that system and understand how powerful the reporting capability is on that particular database. So I'll stop here and see if everybody is clear, right? Does that make sense? How SAP HANA penetrated the market? It started off as a sidecar implementation. Is everybody clear by a show of yes or no? Now, with this information, with getting incredible success in the year 2010 and 2011, by doing secondary, that is sidecar implementation, SAP HANA was becoming a very powerful tool in the market. So when organizations felt the credibility of this product, the next stage that SAP HANA took was, they said, I know you have your OLTP system called SAP ERP. It is still being supported by some traditional database. You have data going into an OLAP system like BW. You took a piece of this information and you sent it to the sidecar system of HANA. You are very happy with the results that we got. Now, it is still dangerous for me to say, go wipe out the database that is supporting your OLTP, because OLTP is the heart, right, for the organization. That's where all your transaction is maintained. It is still too early to say, go replace the database that you have for your OLTP system. But what could be the next place that a company could have gone? They found the success with the sidecar implementation. They might be suffering by adding a BW layer here and keeping complexity on your OLAP system. The moment they found success with the sidecar approach, SAP went and said to the clients, the organizations that has been running SAP for a long time, now that you've seen the credibility of this sidecar approach, I want you to take away the pain you have in your OLAP layer, remove the complexity you have in that system, and replace it with a HANA database. So in the year late 2020, 11, 2012, SAP HANA went from a sidecar approach to becoming a primary database for SAP BW. It's a logical step if you look at it, right? Organizations, this is more of a reporting system. It's not a transactional system. So even if something goes wrong, it is not a showstopper for the organization. So 2011 going till about 2013, the biggest market was for SAP BW to run on HANA database. You might ask me, what was the kind of projects that were available in the 2011 to 2013 timeframe? It was called database migration projects. Companies which was running SAP BW on traditional databases, it could be Oracle, SQL Server, whatever it is, they went and migrated the data from this system into SAP HANA. So by the year 2012, 2013, SAP HANA got the credibility to move from being a secondary database to a primary database. Companies started implementing this. They saw great success with this product called SAP HANA. And in the year 2013, 2012, 2013, they said, I am now bold enough to say that let's go and replace database that is sitting in your OLTP system also. So if you look at the graph of how SAP HANA product came into the market, 2010, HANA came into the market. That's when the product was made available. 2011 to 2012, sidecar scenario. Sidecar is how SAP HANA was being used. Essentially, it was being used as a secondary database. 2012 to about 2014 or so. I would say, I'm sorry, from 2010 to 2011 is when Sidecar, from this time, it became SAP BW on HANA. Then SAP ERP on HANA. By the time we came to 2013, 2014, SAP understood that they have created a revolutionary product called SAP HANA, which is now going to become the central product of anything they want to create in the future. So they looked at now till about from 2010 to till about 2013 or so, they were focused on developing this new database. Would everybody agree? Now that they've got this phenomenal database product, they said, hey, let's start looking at the application layer. Can we do something on the application layer, the SAP ERP layer or the BW layer? Can we do something fundamentally different or redesign that product so that it can run better on a HANA system? That is how in 2014, they came up with this product called as S4 HANA. S4 HANA is nothing but your ERP solution completely redesigned to exclusively work on a database called HANA system. So several products, and then came BW for HANA, and then CRM on HANA became C4 HANA and things like that. So several products are evolving, everything with HANA being its central object of that platform. So does this journey make sense for everybody? We are talking about why SAP HANA came into the market. Now, I'm hoping that everybody gets a clear understanding of why why SAP as a company brought HANA into the market and how did it evolve? How is it evolving in the market? So that is the understanding I want everybody to have about why SAP HANA came into the market. Now, we are saying that when SAP HANA came into the market in 2010, again, this was a product created by a few PhD students working for SAP. So the original product they created was called Trex Engine. So when they renamed it, they came up with an acronym. So HANA was not a product name at that point. It was an acronym standing for High Performance Analytical Appliance. Originally, it came as an acronym, High Performance Analytical Appliance. That is how the name was coined. When it was put in the market, they were only focusing on this being a database. But sooner they realized that this has much more capability in the system. Why did they come to that conclusion is, now let's understand what is inside your SAP HANA system. We are just saying that at a high level, we are saying it's an in-memory computing system. But you are all going to be HANA consultants, right? You cannot leave your knowledge at that lower level. You have to go into the details of what is behind the scenes of this SAP HANA product. If you look at the SAP HANA product, we all now understand that it was not a brand new product created. So there are three components that are combined together to make this product called as SAP HANA. We all know what the first product is, right? Can anybody help me out? What is the first product that is making your SAP HANA system? What is the father technology that was taken? Perfect. The first technology is called Trex Engine. This is the in-memory component of your HANA database. This is what makes in-memory computing work in your SAP HANA. But there are two more components to the system. The second component is called P star time. The second component is called P star time. And there is a third component called max DB. So these three technologies combined together make your SAP HANA product. Now let's take a step further down in understanding why do you need these three capabilities. As I mentioned, the Trex engine gives you the in-memory capacity. How to store information in your in-memory, how to retrieve data from your in-memory fast, like your Google engine. The Trex engine takes care of all that information. But for a database to be called a relational database management system, typically referred to as RDBMS, like your SQL Server, Oracle and all that, there are certain capabilities or functionalities that a database should perform. Only if a database performs certain aspects will it be treated as a relational database. Okay, so I brought the in-memory capability through the Trex engine. But for me to call HANA as an RDBMS database like Oracle and SQL Server, the HANA should also, in addition to the in-memory computing capability, should have relational database capabilities also. Would everybody agree? How do I run SQL statements? How do I process the data? How can I do indexing? How can I do all these partitioning concepts? All these relational database concepts also needs to be introduced within my SAP HANA system. How do I do that? I need a relational database component within my SAP HANA. So SAP company started looking outside the market to see if they can bring any, if they can acquire a relational database like Oracle or SQL Server and bring that capability into your SAP HANA. But now, if you look at Oracle, or if you look at SQL Server, or if you look at IBM DB2, they are full-blown relational database management system, which is, it comes with a lot of overhead. If SAP were to go and buy Oracle's database capability and bring everything into this, if you overload your powerful system, what's going to happen? It's going to start performing slow. Would everybody agree? Though my Trex engine is bringing great capability to improve my performance, if I counter it with a full-blown database capability, I'm negating the effect of my Trex engine. So when SAP company started looking for a relational database, one criteria they had was they wanted a lightweight RDBMS system, which is, it should give me all the RDBMS functionality, but it should not overload my HANA system. So a product that is available in the market was called P star time. P star time is a lightweight RDBMS system. So SAP went and bought this company called P star time, took the underlying proprietary technology of this relational database and introduced it into your SAP HANA system. Okay, so the two components are, this is your in-memory computing capability. This is your relational database capability. So you might think that I have my computing capability, I have my RDBMS capability. Why do I need a third component? So let me ask you all a question. This system is 100% in memory, correct? Every data that I'm storing in this is sitting inside an in-memory system. What is the negative to a in-memory system? Can anybody think of a disadvantage with an in-memory system? Exactly. Manoj is absolutely right. It is volatile. I'll give you a understanding, right? If you have your flash drive or your pen drive, you have all your photos or very important memory stored in that particular hard drive. Would you also not keep a copy of that in some database or someplace in your cloud or somewhere? Why do you normally do that? Because for some reason, if your flash drive, which is sitting in an in-memory system, if it gets corrupted or if something happens, all the data gets wiped out. So you have greater computing capability, you have greater relational database technology. But what if a power shutdown happens or some disaster happens, like an earthquake or something goes and this system turns off? What happens to all the data sitting in your SAP HANA system? It will all go away, right? You will lose the entire data that is sitting in the system because it's a volatile system. Can an organization run their company like that, hoping that there won't be any power shutdown or no disaster will happen? So the MaxDB is nothing but a traditional database concept. MaxDB is an SAP's own database product that was created long time back. It was not very powerful. It was not a very successful product, but it is a database product. The intention of this MaxDB component is only one reason and one reason only. It is here for data backup. So anytime your data is situated in your in-memory, a copy of this data will be stored in the backup. Now you might ask me, are we not redundantly storing the data? Just like when we had the BWA and a regular database, right? In the traditional BWA with traditional database concept, we were duplicating the data for day-to-day purpose. We were storing the data in the BWA to retrieve it and use it for reporting. No matter what, you will always, every organization will keep backup of their data, right? So in this case, this is not used for any reporting capability. This is exclusively used for backup capability alone. Okay. So the Trex engine brings you the computing capability. The P star time brings you the RDBMS capability. And the MaxDB brings you the backup capability. So in case there is a power outage, the moment you bring back the power into the SAP HANA system, all the data from the backup will go back into your memory. That is how your SAP HANA technology is built. Does that make sense to everybody? By a show of yes or no, please. Excellent. So now I'm hoping everybody has a better understanding, right? Why SAP HANA came into the market. And the second, Samshul has a question, is data backup happening continuously? Absolutely. There is a concept called as save point, or in traditional database, it's called a commit. Every time a record is committed in the system, it will get loaded into your backup. Okay. Shrikant has a question. Can you please repeat the in-memory? Oh, I've not even gone into the details of the in-memory concept, Shrikant. I'm just giving you the flavor of what these three products are. In tomorrow's session, that's what we are going to do. In tomorrow's session, I'm going to go take this Trex engine and you will understand what are the different capabilities inside your Trex engine in-memory concept. So to give you a quick flavor, right? There is something called as column store of data. In a traditional database, you store data in a row format. But in HANA database, you will store data in a column format. Then you will understand there is something called as massive parallel processing in the system. Then there is something called as a push down mechanism. At a higher level, these three categories completely explains what this in-memory concept is. So tomorrow I will go into the details of what this difference is with explanation, right? With example. I will show you how a traditional table data will look like. And in a traditional database, how does the data go stored inside the database? If the same table was stored in SAP HANA, how does that information store differently? And how does that help improve performance? Then you will understand how massive parallel processing is going to help you retrieve the data extremely fast. And then there is a very brilliant concept in SAP HANA, which is brand new and not available in other databases, is something called as a push down mechanism. So by understanding these three concepts, Shrikant, you will have a clear understanding of what this in-memory computing is all about. Okay, so that is what we will be talking tomorrow. So tomorrow's discussion, we will start talking about, we have now seen why SAP HANA. We have understood what are the components that makes SAP HANA, right? The three components that make your SAP HANA system. Now, tomorrow we are going to see how these components are working, how these components work. So exactly how the Trex engine is working behind the scene, how the massive parallel processing works, how the push down mechanism works. Once we complete this, we go into something called as a deployment strategy for SAP HANA. Okay, does that make sense for everybody? So for anybody who has joined today, is the context making sense? Anybody who has joined today, can you please, for the first time, can you let me know by a yes or no? Is the pace good? Is the information being delivered correctly? Are you comfortable with the information? And I would also please urge that if you could please take a look at the previous video that we had, that will give you a better understanding of the SAP's product evolution. It will give you a clear understanding of where SAP started and how did they come into this product called as SAP HANA. So tomorrow you will be caught up and you will know all the information that we are talking about. All right. So that's what I want to do for today. So tomorrow we'll continue our discussion about the what about SAP HANA. And then from tomorrow onwards, the duration of the classes will be much longer because I want everybody to settle down, have a level feel, right? Everybody is in the same level. But starting tomorrow, we will start going much, much deeper into the course and I will be taking longer sessions. So we'll probably have a 5-minute break in between and come back and continue to have more discussions because we have a lot of topics to cover and I want to be able to give you all the information I have about SAP. All right. Excellent. So let's get started. So today what we are doing is we are continuing our discussion about our, we are still in the initial stages. We are talking about the foundation for SAP HANA. So we are first in the first section called SAP HANA Foundation. And within foundation, so far we have discussed SAP evolution. Hope everybody is clear with that concept. And then yesterday, we went a little deep dive, understanding what is happening in the SAP product portfolio, right? So we understood why do we need SAP HANA? It's a very critical thing for you to understand because if you do not know the roots of a product, right, you won't be able to appreciate when somebody is talking about it. If you were to defend the product, you need to understand what's the underlying foundation for that particular product. So that's what we were trying to do yesterday. Today, what we are going to do is we are going to take it a little forward, maybe go a little more deep dive and understand. We not only knew why SAP HANA came into the market, but we also understood what is the technology behind HANA. We came to know that there are three products that come together to make your SAP HANA product. Today, what we are going to do is we are going to go one step further down and understand how the technology works. Why? So we are going to understand how this technology, whatever technology we are saying SAP is having, how is it helping it work in a faster performance? So that's what we are going to be looking at. how the technology is helping this product called SAP HANA. So that's our main intention for today. If time permits, if we have completed the topic, we move on to the next topic called as deployment strategy. It's also a very important and interesting concept. If you get into a project at an initial stage, you will be pulled into discussion about deployment strategy. So you'll need to understand and appreciate what deployment strategy is all about. So let's get started. The first thing I want to ask you all is, so we talked about, give me 1 second. We talked about SAP HANA as a product. Can anybody help me out and tell me what are the 3 technology that comes together to form the SAP HANA system? Can anybody help me out? If you could please type it in the screen, right? What are the 3 major components that come together? Perfect. Thanks, Muni. Excellent. Thanks, Samshul. All right. So the first product that is used to make your SAP HANA is your Trex engine. The second product is P start time. And the third product is MaxDB. So we understood these are the 3 components that come into play. This gives you your in-memory capability. This brings your traditional RDBMS capability. And this gives you your backup capability for the system. Now that we have understood this, you need to go a little deep dive and understand what do you mean by in-memory. What is so special about this in-memory computing that it is far superior from its competitors, the traditional databases like Oracle, SQL Server, IBM DB2, right? So let's understand what are the nuts and bolts that goes behind the scene, which makes it completely different from its traditional counterparts. So we said there are 3 major information that is available within your Trex engine that makes it a superior performing system when compared to its competitors. The first thing is column store versus row store. You need to understand and appreciate how is information stored in a HANA database in comparison to a traditional database and how that makes a big difference in data retrieval from your HANA system. The second thing you will understand, so once you understand this, what are you going to know is you're going to understand how SAP HANA stores its data and how it retrieves it in comparison to your traditional databases. And in looking at that information, you will come to know which way is better, how much time is utilized in retrieving data from a column store system than from a row store system. I'll give you the clear distinction between the 2 ways so that you will be able to appreciate what is better performing and what is causing the other system to perform slower. Then you will come to understand, once you appreciate this, you will come to understand what are the other underlying or underpinning technology within your Trex engine or within your HANA system that's making the performance so fast. And that is called massive parallel processing. Then finally, one of the revolutionary changes that they have made in your SAP HANA system, the way a database works, is they have called it as push down mechanism. Again, this is very, very unique to SAP HANA. You will not see it in the traditional databases. So by understanding these 3 technologies, you will clearly understand why SAP HANA performs extremely faster. So just to give you a context, I keep saying SAP HANA performs really fast in comparison to traditional databases, right? I will give you a quick number for you to put things in perspective. When SAP HANA came into the market, SAP went to a very big organization and they did a proof of concept. So what they did was they took an SAP BW system that was running on traditional Oracle database. They identified one table out of this Oracle system, which contains about 450 billion records, raw transactional data, and they created a complex report on top of it. This report was run, and the time taken to run this report on the traditional Oracle database, I think it came to 64 minutes. The time taken to churn the data, the 450 billion records and bring back the information, it took about 64 minutes in the system. Once the baseline was captured, all they did was they took away Oracle, put HANA under it with that same table, that same 450 billion record table, and without making any more changes, they ran the same report. The results for that report came back in 13 seconds. So now you can see just to put things in perspective, right? You can see that what took 64 minutes to run without making any changes by replacing your database, traditional database with SAP HANA, the data came back in 13 seconds. So without you doing anything, you did not go do performance tuning, you did not do any kind of optimization to the system. Simply replacing or switching the traditional database to a HANA database gave you a significant gain in your performance speed. Does that make sense? Does it give you a perspective of what we are talking about when it comes to performance scale? That is why HANA is treated as one of the most highly performance oriented databases in the market. But it's fine to know it in layman terms, right? But how does that help? How do you get that kind of performance improvement? It is because of these three capabilities. So let's go into the behind the scenes and understand what these three products are and how is it different from your traditional databases and how is it saving time and improving your performance. So let's take the first example. The understanding of column store versus your row store. What we are talking here is how when data gets into a traditional database, how does the data get stored? And how when the data comes into a HANA database, how does it store? And is there a difference in the way data is stored and retrieved from your traditional database and your HANA database? So typically what happens, let's say this is my database. Data keeps coming into my system. Let's take an example of a table and understand what's happening. Assume that I have a sales table. Just to give you an understanding of what this technology means, I'm going to just give you a simple table information and walk you through an example so that you can understand it and appreciate it better. So let's assume that this particular table has 4 columns. It has a field called year. It has a field called country. It has a field called product and then amount. Let's call it 2019. Country is, let's say, US. Product is A. Amount is 100. 2019 US. Product B 200. 2019 India. Product C, let's say 150. Let's assume that I have this table stored in my database. Now that I have this table, you need to understand how the data that is coming in this table is stored inside the database. So data storage inside a database the concept is called storing it in tuples. Data storing inside a database concept is called tuples. So data is stored in tuples. That's the idea behind the scene. In a traditional database, like Oracle, SQL Server, and so on and so forth, what happens is the data is stored in contiguous memory location. Contiguous memory location. What does that mean? I'll show you. What happens is, imagine that there is a continuous string of information. it'll take the first record, take the first value, store the information here, 2019. It'll move on to the next value, store US, move on to the next value A, 100. Once it's completed, it'll move on to the next row, store the value 2019, US, B, 200, and then it'll come to 2019 again, India, C, and then 150. This is the traditional route in which data is stored in your traditional database. Contiguous memory, it goes by row, takes each and every value and places that in the memory. So now, this is how the data is going to be stored in a traditional database. In the contrary, the same information. So what is happening? The data is taken row by row and plugged in. So that's why it is referred to as row store or row format. It takes each of your data from your row and then saves it in contiguous memory. In your HANA database, data is going to be stored in a column format or column store. What does that mean? It will, instead of going row by row, it will hit the data column by column. It will take the first column. It is again going to be storing your data in contiguous memory. But now what's going to happen? It will first hit the first column here. It will go through the information that's available and it will take only the unique values that are available in your column. So in this case, the only unique value I have is 2019. So it will only store 2019 one time. Move on to the next column. It will identify what kind of unique values you have here. I have a unique value called US and I have a unique value called India. Then it will move on to the next column, product, and then it will say I have column A, value A, B, and C, and then dollar amount is 100, 200, and 150. The difference is it is storing data column by column rather than row by row. So can anybody see apparently a difference between the way data is stored in a row format and a column format? Is there any advantage that you see in the HANA format? Right off the bat, without knowing much into going into the system, right? Can you just see it and tell me, is there any difference? Excellent. Shrikant is absolutely right. If you look at it, the data here seems longer and occupying more space. Here the data is compressed. Imagine what happens is typically in your traditional database, if you store data, let's say you have 10 terabytes of data stored in your traditional database. If you take that same data and put it into a HANA system, you get a compression ratio of about 1:5 to 1:7. So typically you will, that 10 terabyte data will get stored in the system as, let's say, 2 terabyte or even 1 terabyte. You are getting a humongous compression factor when you store this in the columnar format. But let's get to that a little later, right? Let's understand how row format and column format, we have seen how it stores the data. Is everybody clear as to how data is stored in a row format and a HANA column format? Does it make sense for everybody? How the contiguous memory is allocated? Now let's look at how the data is retrieved from the row format and the column format. Let's say if I ask this question, I need to know the total sales amount for year 2000. I'm sorry, year 2019. This is my question. If I go against my table, I want to know what has been the total dollar amount I have got for the year 2019. So my answer needs to be year equal to 2019. What is the total sales amount? Which is 100 plus 200 plus 150, $450. This is all the information I want out of my table. If I ask this question, and the data is being retrieved from a row format system. What is it going to do? It's going to take the traditional route. It'll first come to the first row. It'll check, is year equal to 2019? It'll come here. It's asking, is my year equal to 2019? The answer is yes, right? So what it will do, it'll move on to the next value, country equal to US. Does it matter whether my country is equal to US or India in this case for my question? My question is, give me the total sales amount. But unfortunately, what happens? The system has to read every value in your row format. It is checking your year equal to 2019. If the answer is yes, it will just say, okay, country equal to US. It doesn't really matter, but it will process that information. Move on to asking what the product is. It doesn't really matter what the product is. It will take the value 100 and keep that in its memory. Okay. Then it will move on to the next record. Check again if the value is equal to 2019. Yes. It will unnecessarily process US value. It will process the product B value. It will process the dollar amount equal to 200. Add that 200 to it. Move on to the next record. Follow the same procedure. Come to 150 and add it. And finally, it will give me the result as $450. So do you see that the system is doing a full table scan? It is processing every single record to identify the dollar amount I need to capture in the example. Does it make sense for everybody? Can you please let me know by a yes or no? The normal retrieval of data in a traditional database goes through format row by row information. If the same question was to be approached in HANA, all it is going to do is, this is how the data is stored, right? If I were to give you a visualization, year column has 2019 value. Country column has two values, US and India. Product has A, B, and C. And then sales amount has 100, 200, and 150. This is how the columns is stored, right? The moment you ask this question, what is the total sales amount for my year 2019? The system is intelligent enough to know that I don't really need to care about these two columns. It will hit this column. It will hit this column. In one shot, it will add these three values and say the amount is $450. So now you can see that it will only process columns that are necessary. These are treated as separate values. And then it will go and identify only the necessary columns and bring information from it right away. So now you might ask me, how does it know that this 2019 is connected to these three records? There is an internal algorithm maintained by HANA system. That's a proprietary algorithm. They do not reveal how it is doing it, right? They have an internal proprietary algorithm that keeps track of these connections. So does it make sense how quickly the information is retrieved when you go from a HANA perspective? It only goes to those columns which is required, and then it will quickly fetch that information directly from it, and then it will bring back the information. So that is the biggest difference you will see when it comes to retrieving the data from your row format and retrieving the data from your column format. Now, to play devil's advocate, right? Is column store always the correct way to retrieve data? Let me ask you this question now. Let's see what the answer would be. I will say, I want all information from sales table where country equal to India. I'm essentially asking all the information. So what does that mean? I want to know the year. I want to know the country. I want to know the product, and I want to know the sales amount where country equal to India. What does that mean? I'll go through this table. In the row format, it will go search. Is the country equal to India? No, it will ignore this record completely. It will move on to the second record. Is country equal to India? No, it will ignore it. It will come to the third record. Is country equal to India? Blindly, it will take this entire record and pass it back to the system. On the contrary, if the same question were to be asked in a column storage, now, unfortunately, I will have to go into all the 4 columns to get the answer. Is that correct? Because I need to know, because my result has to fetch all the 4 values. It has to go look at the column called year. It has to go process the field called country. It has to go process the field called product and get the sales amount. So the thing is, when you are going to be bringing an entire set of record, when your retrieval is going to be a whole record has to be brought down, a row format always performs better when compared to your column format. So let me give you the classification, when to use row format and when to use column format. So let me give you some criteria and say for which criteria row format or column format is better. Typically, when we do analysis, right? When we are doing analytical operations, are we going to be asking for individual record information, or are we going to be looking at aggregated data? When a senior manager or a senior management person is going to be doing some number crunching, are they going to be interested in what a particular product did, or are they going to start at a very high level? Are they going to be looking at aggregated information? What is my total sales for the region? Will they start at higher level, or will they go into detail? So they will go into aggregated information, right? Most of your 95% of your analytical reporting always starts with highly summarized or highly aggregated information. So the question is, if you're seeking for aggregated data, if you're looking for aggregated information, your preference is always column store. Because you understand, right? My first question was an aggregated. Give me the total sales amount for year 2019. You only have to hit few columns in your table. Column store brings back information extremely fast. If the question is, if you have a table, let's say in a real-time project, typically the tables will not have 4 or 5 columns, right? It can have hundreds and hundreds of columns. You can have a table which contains 300, 400 fields available in it. Do we normally run a report and fetch all the 400 fields for reporting? Or do we only select a few important fields and show it for reporting? Typical approach is, if there are several hundred fields, you will probably take like 10 or 15 critical fields and only do analysis on top of it, right? When your request is for few selected fields, if your report needs only few selected fields from a large number of columns, then again, columnar store is always efficient in bringing back data when compared to row format. The third question is, if you want to bring single record, but you want to bring the entire record, everything in that record, or you want to bring few records with all the information available. When you're going into detailed granular level of information, you want to bring an entire record, which contains all the 300 or 400 fields, then row format is always suggested in that case. That is the basic difference you have to understand. When to go for a row format and when to go for a column format. So some of you might now have a question. Because HANA is a column store system, is there even way for me to do row storage and row storage retrieval of data in SAP HANA? That's a natural, normal question you could have, right? The Trex engine in your SAP HANA takes care of everything you need to do with your column storage. Putting data into your column table, bringing data from your column table is all controlled by your Trex engine. But if you all remember, there is also a traditional RDBMS component to your SAP HANA, which is called your P star time. If you wanted to store your data, for some reason you understand that a table that you have kept in HANA is going to be required for row storage retrieval and row storage. In that case, P star time component of your SAP HANA kicks in and it lets you control the data as row storage. So what I'm essentially saying here is, when you come into HANA, when you want to create a table inside HANA, it will ask you a question. When you're creating the table, do you want to store the table as column storage? Or do you want to store it as row storage? It will ask you this question. If you say store the data into this table as column storage, the Trex component will take control of this table and it will maintain it. If you say, for some reason, I think this table is going to be used for more granular type of information, you can say, I want to store it in row storage. The P star time component of the system will take control of it. Now, the next logical question someone could ask is, let's say when you started working on this system, you decided that you want to create the table as a row storage. But after you have created and loaded data, you start to feel that maybe a column storage would have been a better scenario. And I made a mistake. No issues at all. You can switch the table from column to row and vice versa. At any point of time, even when the table contains data, you can switch from row to column and column to row anytime. And I will also, when we get into the system and start working on it, I'll create a column table and then convert it into a row table and vice versa and show you how it is done. Now, the next question is, you might not be an expert initially, right? So when creating a table, without knowing all the information, how will you decide whether I should create a row table or a column table? It could be a daunting question for some of us, right? The SAP has also come up with a best practice suggestion. When in doubt, when you are not sure whether you should create a row table or a column table, ask one question. Is this table going to be used for any reporting capability? If your answer is yes, I'm going to be using this table for some kind of reporting, it says blindly go and create it as a column table. Why they are saying that is, even if you had to retrieve a single record, you can do it using your column storage. The only problem will be that it will maybe take an extra few seconds when compared to row storage retrieval. That being said, it's not a bad thing. So when in doubt, if you do not know where to land, whether should I create a row table or a column table, ask yourself a question. Is this table going to be anytime used in reporting scenarios? If your answer is yes, just go blindly create a column table. Does that make sense for everybody by a show of yes or no? So the first thing we are talking about is, what is the difference between a column store and a row store format? We understood, we looked at in the case of column store versus row store, we saw how storage is affected, how storage happens in a column store and a row store. We also looked at how data retrieval happens in a row store and a column store. We also looked at what are the scenarios in which you would choose a column store versus a row store. Now, let's look at some of the other behind the scenes advantage you have when you go for a column store versus a row storage. I'll take that same example. the table year, country, product, and amount. 2019, quickly write this down. Country US, India, A, B, C, 100, 200, 300. Let's say this is my table. So we know now how data is stored in my row storage table. Is everybody clear as to how the data is stored in a row format? To retrieve data from a row storage, what are the things that you have to do behind the scenes? See, if this table is just containing 3 records, I can always do a full scan of the table, full table scan. I can go through each record and get that information relatively quicker from a row storage. But imagine this table contains millions or even billions of records. Can you afford to do a full table scan, which means I go through record by record, all the billion records and process my information? Would that be a viable option for us? Can anybody help me out here? Doing a full table scan always on my table, row storage table, will that be efficient? No, right? It is going to take me significant amount of time. So in a traditional database, in order to improve the performance, do you have to do anything additional? Anybody with a database background, can you help me out? Exactly. Parni is absolutely right. You will have to create something called as indexes. For people who are not familiar with the database concept of index, let me give you an analogy, right? So that you will get a perspective. If you take a brand new book that you have bought and you want to look for a specific topic in that book, one thing you can do is you can start from the first page, go page by page, flip around each and every page until you find the information topic that you're looking for. That is similar to a full table scan. You start from the first page, you look through everything and you say, okay, I didn't find the topic, moving on to the next page, moving on to the next page, so on and so forth. But is that how we look for information in a book? What is the easiest way for us to find information in a given book? The books always has something called as a table of content. The first page of your book contains something called as a table of content. The table of content tells you if you're looking for this topic, it is in page 10. If you're looking for this topic, it's in page 20, so on and so forth. A table of content helps you quickly navigate to the page that you're interested to fetch the information. Similarly, if you want to bring data from a table quickly, you need to maintain a table of content. A table of content is nothing but, in this case, your index. You have to maintain an index saying that 2019 data is stored in line number 1, line number 2, line number 3. It will store information like this. So the next time you run a report and you want to get information, when you hit this table, it will say, I have an index in place. If you're asking for 2019 data, I know the first 3 records are storing information on 2019. So it will fetch data from here much faster instead of going through a full table scan. Does that make sense for everybody? By a show of yes or no. The reason I keep asking if you could respond back to me is, right, I want to make sure that everybody is clear with the concept. So by creating a row storage in a traditional database, your work is not done. Just because you have a table and row storage, your work is not done, right? If you leave it like that and you start running reports on top of it, the system by default will do a full table scan. Now, in order to improve the performance, you have to do additional steps. You have to maintain indexes on those tables. Okay. The first thing is you have to maintain indexes. Only if you maintain an index on a row store table will you get better performance. And sometimes your report will also ask for summarized data. They will say, I want only to know the total dollar amount used for year 2019. So you can ask aggregated information from your row store data. What is going to happen? To go and summarize, you understood that it will go row by row and fetch the information, right? So in addition to maintaining an index, in a row-based system like traditional databases like SQL Server and Oracle, they additionally create aggregate tables on top of a regular table, which means if they know that what is the most commonly asked aggregated information, they will store another table which will say, I want year and dollar amount to be saved here. So 2019, it will store 450. Tomorrow, if you add another record here, 2019, let's say Japan, D400, you have to go rebuild the aggregate so that it recalculates it and then says it is 850. So what I'm getting here is, with a row storage, the disadvantage that you have are as follows. One, would everybody agree that it takes up a lot of space? There is no concept of compression here. Would everybody agree? Data is stored in contiguous memory. It stores every single value of your data. So it occupies a lot of space. The second thing is you have to create and maintain indexes. You have to create and maintain aggregates. Big maintenance aspect is there, right? Would everybody agree? You have to maintain your own compression factor. You have to maintain your own index capability. You have to maintain your own aggregates for row storage of information. You will see that the reason why when that report was run on that 450 billion record table, why it took 64 minutes or so, it had to go and do all these processing. It had to go identify whether should I do a full table scan? Should I go and identify the index, correct appropriate index? Is there any record that is stored in your aggregated table? It had to continuously churn that information to fetch the data. But in the case of column format, because the data is already stored as columns, individual column, 2019, country is US, India, product is A, B, and C, and dollar amount is 100, 200, and 300. Each and every column is first giving you a high compression ratio. You have already saved space on the table. The second thing is, because they are stored as individual tables, they are automatically indexed. The data is automatically indexed by the system. You do not have to go create, no index is necessary in your columnar storage. And because the data is uniquely stored, the automatic aggregation happens in the system. You do not have to build any separate aggregates for your table. So can you see the contrast between your row storage and your column storage? By just without knowing anything, if you just create a table as a column store, you're automatically getting compression factor. You don't even have to worry about building indexes. Each column acts as an index on its own. You don't have to do anything additional. And there is no need for aggregation capability. This is the biggest difference that you will see in HANA product because of its Trex engine capability. Does this sound clear for everyone? Why columnar storage is far superior from row storage format? By a show of yes or no, please. Excellent. All right. So that is the first concept, right? The second concept is, now that we have understood that the columnar storage versus row storage brings excellent performance in your HANA system, let's back it up with even more credibility. The next one is called massive parallel processing. What does that mean? So typically we know that when we look at Saravana Kumar has a question. Let me see if I can, okay, how is the internal algorithm stored stored, is it stored in a table? It's more of a like data structures, right? Saravana Kumar, I don't know if you've come across this concept of data structures. It's more like a pointer. It will be a pointer. So what will happen is it will say, it will take each column. Let's say the column, let's say if it's year, it will say year unique value is 2019, 2018, 2017. For 2019, it will have a pointer saying for product, it is associated with product A, B, and C. For 2018, it will say product is associated with D, E, and F. And then it will have another pointer which says your country, associated country for 2019 is US and India. And for 2018, it will have a pointer which says it is China and Japan. So it is in the concept of data structure pointers. It uses this algorithm to store the information. So there is some processing involved, right? The moment you say, I want to know for 2019, what is the total dollar amount? It has to go connect that same correct pointer. It has to identify that pointer which represents the connection between your 2019 and the total dollar amount and retrieve the data. But they will not tell us how that particular pointer connection is established, because that becomes a proprietary technology, right? If they start revealing that information, anybody can copy it and duplicate that effort. So that's what it does. Does that help understand your question, Saravana Kumar? Perfect. Okay. Now we have seen with columnar storage, there is excellent compression factor, no index required, and no aggregates required. In addition to that, let's see what other benefits can you get from this Trex engine component. When you look at any server or any computer, a computer or something like that, you will have a component called CPU, Central Processing Unit. That's like your heart of your computer. Would everybody agree? A CPU determines how well your system performs. Any processing you do in your computer, whether it's your laptop or your desktop, it tells you how fast your system is going to perform is going to be determined by your central processing unit capability. Now, traditionally, decades back, when you had a desktop or laptop, it will have one CPU. That's it. And it will have a CPU will have one core, which means it is processing ability, right? But nowadays, what do we see even in our laptop? If you go buy a Lenovo laptop or any HP laptop or anything like that, it will say it is a Quad Pro core CPU. What does the quad means? Quad Pro, it contains, the CPU contains 4 cores in it. So imagine this is your CPU. There are 4 cores inside it, core 1, core 2, core 3, and core 4. So there are individually 4 different sections within your CPU that can individually process on its own, independent of each other. So imagine I am asking question 1. The question 1 can go to core 1 and get processed. At the same time, if I'm asking another question 2, it can go to core 4 and get processed independently. Parallel processing is happening here in the core. So in a traditional server, what you will see is there will be a motherboard. A motherboard will contain a CPU. A CPU will contain a core, and that's where all your processing will happen. Would everybody agree? I mean, that's the traditional approach, right? In the case of SAP HANA system, it is a HANA system is not only your software component, it is also having an excellent hardware component inside it. What do I mean? The software component is your columnar storage. How the software is behaving to perform data retrieval and data storage. But if you do not have the right hardware capability, if your system does not have the right hardware, right, can it do all the processing much faster? It cannot. So The hardware is normally supported by different vendors. Intel, Cisco, HP, Fujitsu, Dell, all these companies provide the underlying hardware technology. So Munib has a question. So does it mean that HANA cannot be installed on any machine? No. HANA has to be a complete server by itself. You cannot just download, like downloading, if you wanted to download SQL Server, right? You can download it on your system. You cannot do that. It has to be done exclusively on a separate system. And we will get to that information, Munib. What are the requirements you need to have installed to install your SAP HANA system? It is always a combination of your software and your hardware capability. So now, hardware, what does it mean? They provide one of the best hardware for your HANA system. How does it mean? Their hardware is built such a way that it contains multiple motherboards. Not one motherboard, it contains multiple motherboards. Each motherboard contains multiple CPU. And each CPU contains multi-core. So look at the processing capability it's now going to have. You're going to have, just within one CPU, you're going to have multiple cores. And within the other CPU, you will have multiple cores. So when your data is stored in columnar format, for example, like year, country, product, and amount, when you already have it stored in columnar format, when I say the question, I want to know for year 2019, what is the total dollar amount? What the system does is, first, you have already got compression factor, no index needed, no aggregation needed, because the way data is stored. But to retrieve the data, what happens is the system will do, because of this massive parallel processing capability, MPP, year's information can go into one core. The dollar amount can go into another core and get processed independently. And data can be retrieved back extremely faster. So because of the software, you had great compression, great capability of indexing and aggregation without you doing anything. That's the software component of it, right? Backing with that, if you have this massive parallel processing hardware capability, the processing power increases exponentially. Okay, so that is the second capability that Trex Engine and SAP HANA has. Not only your columnar storage, but it is being backed by a massive parallel processing capability. So those are the two credible information we know about SAP HANA's Trex Engine, right? The third engine, the third capability is called the push down mechanism. A very important topic. Let's understand what happens in a traditional system and how HANA is different in the third concept. In a traditional system, let's take SAP BW or SAP ERP system, any system, right? So this is your software layer or your application layer. Is everybody comfortable with that naming terminology? So the moment I say SAP product, it will always have two components, right? One is your application layer where your software resides, and you will have a database layer where your actual data is residing. This is how you should always visualize when I say some system, right? When I say SAP ERP system, you should think there is an application layer and a database layer. Now, when a report is run, when some user is asking for a report, what happens is, let's say this report needs complex calculations to perform. Let's say it has to do a lot of business logic to retrieve the data from your database layer. In the traditional world, in Oracle, in SQL, and all these systems, you cannot store any application logic. No application logic can be performed in a database. So what typically happens is, application logic is always stored in your application layer. When I say application logic, business logic, just think about complex calculation. So when this report is expecting that you should do complex calculation, what happens is it will first come talk to your application layer. It will say, hey, I'm looking for this information. Can you give me that? Do I have data sitting in the application layer? Do we have data sitting in the application layer? No, right? So what does the system do? It will say, okay, I'm going to talk to the database and fetch the data. It comes here, it gathers all the data that you need. Can I perform any logic in my database? I cannot, right? So what happens? Second step, it is talking to the database. Third step, it is collecting your data. Fourth step, it is sending all the data back to your application layer. The data will now temporarily reside in your application layer because your data needs to be applied with the application logic. And then step 5, it sends the data back to the reporting screen. So anytime there is complex calculation involved in your reporting, it has to take this 5-step process to retrieve the data. So what's going to happen? Performance takes longer time because you cannot have any application logic built on your database. The time taken for the communication, it's called I/O processing. The input-output processing between your application layer and your database layer significantly is increasing. Does that make sense for everybody? Hope the point is clear for everyone. In a traditional database, because the database cannot understand and do calculation on your application, it cannot do application logic or business logic. Anytime a report is asking you to do calculation, it will go to the database layer, take that, let's say 1 million or 2 million record that is needed for the calculation, bring it up to the application layer, do all the number crunching at the application layer, and then show the report information. So the data is pushed up to the application layer for calculation. So every time we have to do a calculation, you are pushing unwanted amount of data into your application. An application layer is a presentation layer, right? Is a visual layer. If you bombard the visual layer with too much data, it's not going to act in a very high performance way, right? What is it going to do? It is not built for number crunching. An application layer is only for visually showing information. But we are abusing the application layer by bombarding it with so much business logic it needs to work on. So what happens? The normal time taken to process this data significantly increases. On the contrary, what did SAP HANA do? They said, we all know that no matter what product you take, there is going to be some heavy intensive operation that the application layer is going to be asked. Can we figure out a way to not do that? So what SAP did was they said, you keep your application layer as is. My HANA system is not only a database, but I am giving it application credibility also. It also contains the application layer component inside the database. So now what happens is when you ask an extremely complex report to be processed, this ERP, the application layer will say, hey, this is the information I'm asking for. It will take the data, apply the business logic right there. It will not even pass the information back to the system. It will do all the application logic calculation here, and only the resultant data is sent back to the application layer. So imagine 1, 2, 3, and 4, the data is back to the report. So all data processing is done now directly in your database layer. You don't have to push the data back to your application layer to perform any intensive operation. So that makes that much of your processing faster. So that is what push down. So you're pushing down all application logic directly into your HANA database. That's why it's called push down mechanism. So, so Manoj has a question. Is this similar to the push down functionality in business object data services? Sorry, 1 second. So the question is this similar to push down functionality in business object data services? Correct. So even in business object data services, Manoj, that's what you do, right? You bring the data and then the data is processed within the database and you retrieve the information. The concept is very similar, but then business object data services, think about it as more of an ETL tool, right? So its scope is limited. But if you're doing day-to-day operation for reporting, it makes a bigger deal for us, because if you did not do the application processing, everything has to go up and get it processed and bring the information. So it's going to take a significantly longer time. So does that make sense for everybody? Parni has a question. How do you program the business logic? So there are, when we go talk about the technical architecture, Parni, what happens is you will come to understand in your HANA system, there are 5 different engines that are available. There is a SQL engine. There is an MDX engine. There is a planning engine, and there is a SQL procedure engine and a calculation engine. There are 5 different engines that are capable of doing application logic processing. Depending on what type of calculation is asked, it will choose between the 5 engines, and these engines are already inside your HANA database. So it knows which engine to activate, and it will do the number crunching right here instead of asking the application layer to do it. Okay, and you will understand it better when we get into the technical architecture. Okay, it will become very clear to you in what scenario which particular engine will take care of processing the data. All right. So now what we have seen is, we have seen why SAP HANA. We have seen what are the 3 different technologies that make your SAP HANA. And now we have also seen how SAP HANA technology is working together. What are the great points it has? It has columnar storage that gives immense advantages. It has massive parallel processing, and then it has push down mechanism. Does this make complete information? Does it give complete information for everybody? If somebody is now asking you, hey, what is making SAP HANA a super power processing system? Is everybody comfortable answering that question? Perfect. Srikanth has a question. If compressed also, how much amount can be stored in memory? Is there a limit? Very good question, Srikanth. SAP HANA is bought in memory chunks. When you buy SAP HANA, the license amount you pay is for the amount of memory you buy. So typically you buy in 1 terabyte, 2 terabyte, 4 terabyte, 10 terabyte. How the memory amount you buy, that is what will cost for your license. So that will be in millions and millions of dollars. Okay. But if you buy 1 terabyte memory of HANA database, you can traditionally, if you had stored like 5 or 7 terabytes of data in your traditional database, that can be stored in the compressed 1 terabyte itself. So even though you're paying millions of dollars for 1 terabyte system, it has the compression ability to store 5 to 7 terabytes of traditionally stored data in the system. Okay. At this point, I think, see, the vendor that serves these memory are, as I mentioned, Intel, Cisco, HP, and all these different companies, right? I think right now, the biggest you have is a 16 terabyte system. You can buy multiple 16 terabyte systems also. But traditionally, I think if my memory is right, it's 16 or 24 terabytes is the largest memory you can get in one box at this point. But I could be wrong, because every day competitors are bringing in new product, right? So that's my last memory. I could be wrong. Okay. But did I answer your question, Srikanth? Typically, the largest I have seen is, I think, 16 terabytes. HP has a product like a super dome system, which is like 16 terabyte system, but I could be wrong. There could be somebody else who has built a much bigger system now. But this is very, very critical information for you to understand. Okay, so that is what, so if everybody is, to do a quick recap, right? What we have learned is, we learned about the SAP evolution. Once we are appreciated what evolved in the SAP product, we came to know why SAP HANA came to the market. So is everybody comfortable talking about how the product of SAP evolved? A very high level, you're able to now understand and say, hey, this is what has happened, right, in the SAP market. Then you're able to talk about why SAP HANA came into the market. What was the limitation with BW systems? There was this BWA accelerator you had to use. And because that was not performing really well and it was a maintenance nightmare, we went into this product called SAP HANA. Then we understood what is the technology behind SAP HANA. We know that it has Trex, it has P star time, and it has max DB component. Or one thing I forgot is Trex. What does Trex stand for? Text retrieval and extraction. The engine's name is text retrieval and extraction. That is what Trex engine stands for, text retrieval and extraction. We understand this, and we also saw how this technology plays together. And of course, when we have already seen the timeline, right? 2010 is when it started, and we looked at the time evolution also of SAP HANA product, how it started with a sidecar approach, and then it was a secondary database. Then we moved on to being a primary database, and then we moved on to S4 HANA as its core systems. We have seen that also. So Samshul has a question: is there any limitation for records in column-based table? Correct. So if you remember, the limitation is, if you were to bring individual record, if you wanted to bring a single record from your table, then your columnar processing is a little more expensive when compared to your row storage format, right, Samshul? Because in a row storage, the moment it hits a specific record, it can blindly bring that entire record and show it to you. But to bring a specific record in a column storage, it has to go into each one of those columnar storage columns, fetch the data from each one of them. If there are 300 columns, it has to go process it 300 times and fetch all the information and collect it together. So that is why it is a little more expensive when it comes to individually pulling records from a table. But that being said, can it not perform? No, it will perform. If row storage brought back in information in 2 seconds, column storage might probably bring it in 3 or 4 seconds. It is still fast, but it will be a little slower than a row format in that particular situation. Okay. Srikanth has a question. Now it is same database for both OLTP and OLAP system. Then BW, will it exist or needed in HANA? You're absolutely right, Srikanth. That is correct. So what Srikanth is asking is, now that HANA has become so powerful and we have gone into a system called S4 HANA, which is nothing but it is replacing your current world ERP. In the traditional world, ERP was my OLTP system, and to support reporting, I had to build a BW system called OLAP system. I needed an OLTP and OLAP system to run my organization, right? 2 separate systems were required traditionally. Now Srikanth is asking, because now S4 HANA S4 is nothing but your ERP system. It's so traditionally an OLTP system. But because it is sitting on a HANA database, it is also now acting as an OLAP system. So because I can use my S4 HANA system both as an OLAP and OLTP system, Srikanth is asking, is there really a need for me to go and buy a BW system separately? The answer is, if your organization has been always using BW as a product, right, Srikanth? The Answer is they will traditionally say, yes, we want to continue to use BW because you already have skill set and resources who are trained in BW. You don't want to just throw it off tomorrow and get done with it, right? For companies which has been traditionally using BW, they'll continue to use that in their roadmap. But if your organization is brand new to SAP and they've started their journey directly with S4 HANA, then there is no need for them to go buy an additional system called BW. So it is only for people who are already using BW and they want to continue in that journey. SAP has recommended that product. If you do not need it, there is no need for you to duplicate the effort and bring an BW system. Does that make sense, Shrikant? Okay, so that is what I wanted to cover. So maybe I think Saravana Kumar has a question. Let me look at that. License is based on memory. Does it mean that for in-memory alone or for the database? So there is no separate component, Saravana Kumar. When I say HANA database, when I say my HANA database is a 2 terabyte database, this entire 2 terabyte is on memory. So you are only paying for the memory. The additional max DB component comes with your license. So typically what happens is if you have a 1 terabyte system, the recommendation is you at least have a 4 terabyte max DB component. That's the traditional database component. Okay, that is for your backup information, but you will not be retrieving information from here for reporting, right? So when you say I am buying a HANA system of 1 terabyte memory or 2 terabyte, your entire database is 2 terabyte. All the information you store in the system is going to be within that 2 terabyte memory. Okay, the additional max DB component is for your backup that comes according to your configuration. If you say you go for a 2 terabyte system, typically it is 4 times your memory capacity. That is what your max DB component will contain. Okay, Samshul has a question. You mean S4 HANA is fine with two-way traffic? It is fine with two-way traffic, absolutely. Again, you have to see the resource contention is something that will always be there, right, Samshul? In the traditional database, we said the main intention of an OLTP system is to bring transaction inside and store it efficiently in its database. If you think that you're overloading this information from with read capability also, then you can always send this data into another HANA system, and that HANA system could only be used as an OLAP system. But if you had the large amount of resources and you're capable of managing both OLTP and OLAP in the same system, then you can live with one single system. The answer to this, is OLTP and OLAP capability available in S4 HANA? Yes, because it is being supported by a HANA system. Do I have all the resources to do my OLTP and OLAP processing in the same system? That's a question, infrastructure question. If you do not have the right resources to do it, then you can bring another HANA system and store the data and do that OLAP processing in that particular system. Okay, that depends on your company's resource capability. If they have the right resources, they can go ahead and do that processing. So is this concept clear for everybody? I know I took a little longer time to explain this concept. The reason I did that is I want to make sure everybody's fundamentals are strong. If you get the fundamentals right, then as we progress now, we will be dealing with a lot of difficult concepts, right? You should be able to easily understand and appreciate the concepts that we're going to be talking in the future. All right. So that's what I wanted to do. I was thinking of starting a new topic today, deployment strategy, but it's now already close to 9 a.m. Central. So what we will do is in the next week. So as I mentioned, from next week onwards, it will at least be a 3-hour session. So please be prepared. We'll maybe give a 5 minutes break in between. But next topics we want to cover is in the next week, we want to finish off deployment strategy. We want to finish off deployment options, and I want to start the look and feel of the system, look and feel of HANA, and technical architecture. My goal is I want to finish off the foundation layer of SAP HANA by next week. So once we have done with that, from the following week, so right now the schedule is 7:30 a.m. Central. That's when we start, Munib, right? That's what we have agreed upon, 7:30 a.m. Central, Saturdays and Sundays. Is there a way we can get a better schedule? I mean the material. I don't follow the question. Could you explain it a little bit better, Munib, if you don't mind? Can you type out what you're thinking? Idea is we want to finish off the HANA foundation and then get to the exciting part, right? We want to next start with data provisioning. From data provisioning onwards, it's going to be hands-on. We will go into the system daily and work on the system as I explain the concept to you, so that it will be much more interesting for you to interact with the system. All right. Hope, so just, I want to take a pulse, right? Is the content clear enough for everybody? So Munib is asking, we are having 1 hour at, the reason I'm having 1 hour at a time initially, Munib, is because I want to make sure everybody is in the same level field, right? Because there could be few candidates in the class who are not from an SAP background or not from an IT background also. So that's why I'm taking it a little slow to give you the concept clearly. But as I said, from next week onwards, it will at least be a 3-hour session. It will also potentially go for a 4-hour session, depending on your appetite, right? I can go for hours together. I want to make sure that everybody is also comfortable. I don't want to scare you away, right? So that's why. So from next week onwards, absolutely, it's going to be much longer sessions, conveying a lot of information for you. Okay. So just want to take a pulse. Everybody, are you comfortable with the way the course is being taught? The content is being presented and the examples, is that making help? Is it helpful for everybody? Excellent. All right. So from next week onwards, we will go into depth and try to cover a lot more information. At the same time, I won't compromise on the quality of training, right? I want to make sure that everybody understands the concept also. That is even more critical. Okay. So we'll definitely take it to longer duration starting next week. All right. Thanks everybody. You have a great week. So Munib has one more question, I believe. Let me wait for it. And then we'll close the session for today. Munib has a question. Do we need to install anything? Absolutely not. So by next week, they will close the batch. They're already saying that they've come to closing the batch. They've got all the students. So once all the students have been logged in, right, they will give you connection to a remote server. You just need to log in into that server. They will give you an IP address and a user ID password. You will just connect to that remote server. All the tools are installed in that server. You can start using them and playing with that access. Munib has a question. Can we access remote through iPad? Absolutely. If your iPad has the capability, processing capability, you can connect to remote desktop from your system. Then you can always practice from there. Bhaskar has a question. Are we covering certification question? Absolutely. So all the topics that I talk about, right? The concept of Trex engine, the difference between columnar storage, row storage, what is happening with the push down mechanism, what's happening with the massive parallel processing. All those are certification questions. All those will come in handy when you go to certification. These are the things that will be asked as a question, right? So we are explaining, as I go through the topic, I will also stress out on the point. These are all basic information. But when you get into the crux of the course, every time I touch upon a point, if I think that it is certification relevant, I'll call it out and I'll say, hey, remember this will be a certification topic for you. All right. So I'll stress on that fact. Absolutely. Thanks, Muni. I'll wait for a couple more yeses just to make sure everybody can hear me. Can I get a few more people to respond, please, if you don't mind? I just want to make sure that I'm audible to everybody. Thanks, Jayasudha. Appreciate it. All right, let's get started. Let me share my screen. All right. Let me open up the chat window just to make sure I can see everybody's comments. All right. So today what we're going to do is we're still in the discussions about SAP HANA Foundation. So this weekend will be the last discussion that we have on SAP HANA Foundation topic. Starting from next week onwards, it's all going to be hands-on. So we will get into the crux of SAP HANA, which is how do we start doing data provisioning. That's what we are going to do. So this weekend is going to be a lot of information that's going to be covered. So today what we are going to do is we are going to be covering two important topics. The first one is called deployment strategy. And the next one is called deployment options. So a word of caution to everybody. Again, as a HANA consultant, you are not expected to know this information. This is more of a soft skill for you to have. When I say soft skill, I'll set the context for you so that you are aware of what we are trying to cover for today's session, right? Typically what happens is, give me 1 second. So this information, this is hardware related information. What do I mean by hardware related information is, how do you get the infrastructure ready for HANA? That's the discussion that we are going to be talking. Why is this an important skill for you? Is as a HANA developer or a HANA consultant, you are not expected to know infrastructure level detail. When I talk about infrastructure, I'm talking about the HANA server, the HANA CPU, the HANA memory, the HANA network, and all those capabilities, the operating system and all that. You on a daily basis, you're not going to be talking about that. Then you might ask me, what is the context? Why? Sorry, I can hear some background noise. If you could please go on mute, I would really appreciate that. Okay, thank you. So what I'm saying is, it is good for you to know, this is a very good soft skill. When you get into a project, when let's say, for example, you're fortunate enough to get into a project where they're just kicking off HANA initiative. They have not started working on HANA. They're just in the initial stages. What happens is, Ling is saying, could you speak louder? Am I audible to everybody? Can everybody hear me clearly? Could you give me a yes or no, please? Ling is saying he or she is asking me if I could speak a little louder. Okay. All right. Excellent. So Ling, looks like everybody is able to hear me. Hopefully you have your audio settings set high. Please try that. If you have any issues, please let me know. Okay. All right. So what I was going to say is, when you get into a project, the initial discussions, the high level strategy discussions are going to be held with senior management people, the directors of your project, the business project sponsors. They are the ones who are going to be involved. When you are fortunate to get into a project at that time, what's going to happen is you can share some valuable information when it comes to deployment strategy and deployment option. This is going to be mainly a discussion that's going to happen between senior management and infrastructure team. Your organization will have an infrastructure team which deals with network, which will deal with servers and all that, server architecture and all that. But if you get into that early stages, you can contribute, you can give them suggestions. What happens? Your credibility goes extremely high, right? Because you are now showing your knowledge to senior management people. You're already setting your credibility. So let's put this in context. Again, if you do not understand everything about it, it's not a showstopper, because as a developer, you're not expected to know this information. But I want to give you this so that you get an overall perspective of what we are doing with HANA. So the first question is deployment strategy. First of all, what does it mean? Putting it in layman terminology, right? What does deployment strategy mean? We have understood about SAP HANA now. We have answered all these questions, why when, what, and how. All these questions have been answered. Now the next question, deployment strategy talks about where does HANA system reside? This is a question that your organization is going to ask, right? They are going to ask, now that we have decided to go get this HANA product, where should we reside? Where should we keep this HANA system? So there are potentially 3 different options where you can keep your HANA system. The options we have are: 1, you can keep it on premise. You can keep it on cloud, or you can keep it in a hybrid option. So in the deployment strategy, we are going to understand what are these 3 different options, how it makes sense to put it either in on-premise, on cloud, or using a hybrid. Hybrid is nothing but a combination of on-premise and cloud option. So let's quickly understand. I'm sure most of you have already heard about on-premise, on cloud, and things like that. I'm sure people who are already working in IT, you will be hearing at least this terminology cloud very so often, right, nowadays. For the benefit of few people who do not understand what the difference is, I'll give you an understanding. In a traditional setup, when you take an organization, let's take a simple hypothetical scenario, right? Let's say I have an organization called ABC. This organization is based off in, let's say headquarters is, I'm from Houston, so I'll say it's based off in Houston, Texas. So what happens typically if the headquarters of this organization ABC is in Houston, Texas, all their employees are going to be located in their own building, just for example, right? All the resources, human resources are going to be located in this particular building. Traditionally, what happens if this organization has a lot of applications, right? Let's say, for example, they are running Oracle, they are running SQL Server, they are running .NET applications, they are running Microsoft applications, so on and so forth. For all these applications, you need hardware to support. Would everybody agree? So let's put things into context. When I say hardware, from now on, right, what I would like for you to remember is, keep it very simple. Hardware comprises of 3 main things. It contains a network layer. Network is nothing but your fiber optics network, the wires that's passing from one place to the other to connect your different servers, right? Think about network, think about servers and CPU. That is nothing but your storage place, right? And your database. So going forward, if I say hardware, just think that I'm talking about a combination of all these 3 products. So if I am running an Oracle application, if I'm running a SQL Server application, would everybody agree that I need some kind of an hardware to support it? I would need a database, I would need a respective CPU and servers in place. I need the network to connect these different servers. So it is either called hardware, or the fancy terminology for that is called infrastructure. So in the traditional world, when a company has its people sitting in its own building or rented building, the approach is they will also have a building which houses all their infrastructure. They might have a building which will hold all their infrastructure in place. The correct name for this building is called data center. Typically, you will hear this terminology. An organization will say, my data center is in a certain place. So far, is it making sense for everybody by a yes or no? I just want to set things in perspective, right? Your infrastructure has to be put in place. That infrastructure resides in a building. That building could be owned by you, your organization, or you could be renting it from somebody. But that building where your infrastructure resides is called data center. So typically organizations, what they will have is they will have something called as a primary data center, where all your infrastructure, main infrastructure is in place. that will typically reside close to your headquarters. So somewhere close to Texas, you will have your data center. There will be another building which will contain the same level of infrastructure, and that is called secondary data center. Can anybody help me out why you would need secondary data center? Why would an organization keep a secondary data center? The reason is for exact disaster recovery. In case there is some power outage or something happens and your primary data center goes offline, what happens? Automatically, the company is now able to connect to the secondary database. This will be somewhere else. It could be in a different state within the United States, or it could be in a different country across the globe, anywhere it could be. So they will always have, typically organizations will have a secondary data center where your information is secure. So in case your infrastructure gets hit by an earthquake or some kind of a natural disaster, you automatically switch to the secondary data center and you're able to continue running all these applications. So this is the traditional approach an organization used to take. So when you store all your infrastructure in your own building or in a building that you're renting, it is called on-premise data center. On-premise is nothing but your own premise, your own building where you're holding your infrastructure. That is called on-premise solution. So the option is an organization can decide to choose to keep their HANA system, the infrastructure needed for your HANA. What does that mean? Your database, your server CPUs and your networks and all that, they can keep it in their own building, and that would become an on-premise solution. Now let's understand what are the advantages and disadvantages of using an on-premise solution. If you look at on-premise solution, sorry, I can hear some background noise. If you could please go on mute, I would really appreciate it. Thank you. What's happening with the security, right? I can have a tight security on my asset. Second thing, I have maintenance power. I can decide and choose when to maintain my infrastructure. I have complete control over my maintenance. Because all of my infrastructure are my own infrastructure, my own network, my own servers and CPUs, my own database, they are assets to my company. Would everybody agree? Because the building is my own building and my infrastructure is inside my building, I have high security. Because it is all my infrastructure, I decide when to upgrade, when to maintain, when to do patchwork, when to stop and start my infrastructure. All that control is given, complete control is given to my own organization. Because these are all products that I bought, it is my asset. So these are some of the biggest advantages, right? Let's look at the disadvantages. Disadvantage, of course, cost. Because I have to maintain the building, I have to pay rent for the building, I have to pay for the infrastructure and buy it. The cost of buying and maintaining is going to be extremely high. Does that make sense for everybody? So that is the decision that an organization takes. When an organization is deciding about how to do a deployment strategy, should I do on-premise or should I do cloud option? What are the things that they are going to weigh in is going to be these considerations. Is security a high concern? If you are going to be holding, if you're a banking institution, what is going to happen? The system, the organization is going to say, no matter what, I want to store all my infrastructure in my own premise because of high security. I don't want to take a chance and send it to somewhere else. So I'm going to, even if I'm going to be paying extra money, it is beneficial for me to store all the infrastructure in my own building. So those are the considerations a senior management is going to take when it comes to on-premise. So now let's take a small deviation from here. Let's understand, when let's say your company has decided that I want to go with an on-premise solution. How is HANA as a system available for an organization? So let's say, for example, if my company decides that I want to go buy HANA as a product, how do they buy the product called HANA from the market? What happens is, there is two pieces to a HANA product, right? Always there is a software component and there is a hardware component. Would everybody agree? Software is nothing but your software license. You need to buy the HANA license, right? That is the software component of it. But in order to run this software, you will need the respective hardware. What are we talking about? The database, the server, the CPU capability, the network capability, and all these you need to buy. So these capabilities, the hardware capability, are given by approved SAP vendors. Some of the vendors I had mentioned earlier, Intel, they can go buy it from Cisco, HP, Fujitsu, Dell, so on and so forth. There are so many companies now available which are offering the hardware component for supporting your HANA software. So yes, now
I just received it just now.
Sorry, I can hear some background noise
for the session, not for the class link.
Gentle request to everybody, if you could please go on mute. I would really appreciate. The reason is we're recording the information. It will help others if you missed anything, right? When you're going back and looking at the video, it would help us. Thank you. All right. So we understand that it is a component. The HANA component can be bought with both software and hardware bundled up, right? So how did organizations, when SAP started off delivering this product called SAP HANA, it came out in the market in 2010. How did SAP product this market HANA initially is? They sold it as an appliance. What is an example for an appliance? You go to a store like JCPenney or Sears or any of these places, and you decide that you want to buy a fridge, a refrigerator, or let's say you want to buy a washing machine or examples like that. Do you go to a separate vendor and say, give me the license for running the washer, and then you go to a separate place and get the hardware for it? Or do you get everything bundled up together as an appliance? You get one box. That box contains the software and the hardware. All you have to do is just plug it in, turn it on, and then start using it. That is what is called, say, example, just for you to understand what an appliance is. Think of it as a bundled product. HANA was only available as a bundled product. So what SAP did, SAP had a tie-up with all these hardware companies. You as an organization, you will say, I need a 1 terabyte HANA system. When you say that I want a license HANA system for 1 terabyte, they will say, okay, you can go to Intel or you can go to Cisco and you can go to HP or any of these approved vendors, and you can say you want the HANA system. They will bundle up the software and the hardware and ship it to you as one box. So when in 2010 going till about 2012, an organization could only buy a product as an appliance, which means that you cannot mix and match anything. You say, I want HANA system. The vendor, in coordination with SAP, they will send you one big box. This box will contain the software HANA, and it will contain the hardware layer, which is your database, your server, CPU, all your network needs. Everything will be bundled together and shipped to you as one box. Now let's take a look at in the year 2010 to 2012, what was the advantage and disadvantage of this approach? Can anybody think what the significant advantage would be? The organization does not have to go to multiple places to get this product. It comes as one bundled product. So easy installation. Right? I don't have to do any kind of work. Everything comes pre-built. I just need to plug it in and start using the system. So the biggest advantage is the time taken to get this product would be quicker. Would everybody agree? Because it already comes as a bundle. I put in an order. They will ship, they will build everything. The vendor company will build the entire system and ship it to our organization. So the time taken is relatively small and easy installation. Could anybody think what could be the disadvantages? For sure, one of the disadvantages, because it comes as an appliance, right? The cost is going to be extremely high. On the contrary, Srikanth, so Srikanth is saying flexibility, and I will explain that point to you, right, to get clarity. So would everybody agree that cost is, so let's say, for example, if you go to like a Best Buy or some other shop, right, electronics shop, and you say that I want to build I want to buy a laptop, or I want to buy a desktop. If you buy a product which is already assembled and kept ready, the price on it is going to be higher. But if you wanted to build your own HANA system or your desktop, you could pick and choose the RAM you want, you can pick and choose the hardware you want, you can pick and choose all the information by yourself, and maybe you can buy cheaper products and build a similar looking desktop for a little lesser price. So typically anything that is pre-built and given to you is costly. On the contrary, Srikanth, it is less flexibility. I will explain why it is less flexibility, right? Less flexible. Because it is already pre-built. Let's say you went and said, I need a 1 terabyte HANA system. They have configured your database, your server, and your CPU to satisfy a 1 terabyte requirement. They will probably give you a little bandwidth to increase your space. So tomorrow, in 3 years, you have already utilized the 1 terabyte. They would have given you space to grow for another 1 terabyte. That is, you can go ask your SAP system, tell them, hey, I want to increase my license from 1 terabyte to 2 terabytes. They will probably give you small section to grow. The growth opportunity in an appliance is limited. You can only grow to the maximum. So let's say when they ship this box, they will say, we have installed 1 terabyte capacity. It can maximum grow to 2 terabyte. I'm just giving you an example. The maximum you can grow is only up to 2 terabyte system. But what if your company's need extends the 2 terabyte and they want to go into a 6 terabyte or an 8 terabyte system? They will have to go get another appliance altogether. Does that make sense for everybody? Perfect. Yeah, I think then I misunderstood you, Srikanth. So I think we are on the same page, right? So it is less flexible. Okay. Does it make sense for everybody? So that is the information. Though it is quickly available, it's the time taken to get it is easy. The disadvantage is it is very costly, and it is for the pay money you're paying, it is very less flexible. You cannot. So what happened? Initially, because companies did not have a choice, from 2010 to till about 2012, companies started buying HANA as an appliance. That was the only option available. But imagine if I am a company like Pepsi or GE or some big company, right? Of course, I will have a very big data center. What is going to be inside my data center building? I'm going to have several servers. I'm going to have several CPU available. I'm going to have a plenty of network, let's say server, CPU, network. All these could be available in abundance. Some of the servers could be used for Oracle application, but I could have several servers sitting in my organization not being used. So companies started complaining that, hey, your product, you're letting us only use your own appliance, which means I have to use only your server, your database, and your network and CPU and so on and so forth. I have no flexibility. But because I'm already maintaining a big infrastructure, my data center contains all these capabilities. Why are you not letting us build our own HANA system? So that was a big argument that was going on between SAP and the organizations, right? The clients who are buying this product. So in 2012, SAP said, we understand that this is becoming a common challenge across different organizations. So they introduced another way of getting SAP HANA. So the first way of getting SAP HANA is SAP HANA as an appliance. Is everybody comfortable as to what we mean by SAP HANA as an appliance by a show of yes or no? So we are still talking about on-premise solution, right? We are in the on-premise. We are saying if you wanted to buy your SAP HANA, you would opt for HANA as an appliance. The other option that was started in 2012 was called TDI approach. TDI stands for Tailored Data Center Integration. What does it mean? It sounds like a fancy name, right? All it means is all the organizations went to SAP and said, I know we cannot go and buy SAP HANA license from anybody. We cannot create our own license, right? SAP HANA license is still something we have to get from you guys. The associated HANA database is something I have to get from you because I might not have a sitting HANA database in my organization, right? If this is the first time I'm buying HANA, I'll probably have to get it from SAP organization. I'll have to go to your vendor and get the HANA database. But keeping these two aside, my hardware layer, which is my CPU, my servers, my network, all these, I should be able to reuse whatever I have within my data center. This is the argument that companies put forth. So what essentially this name is saying is, can I use whatever I have sitting in my data center and add it, associate it with your product called SAP HANA. Combining your own data center related hardware with the SAP product called HANA. Sorry, I can hear some background noise. All right. So that is called tailored data center integration. SAP said, okay, we will agree to it, provided the hardware you choose to use has to be certified by us, by SAP. Does that make sense? SAP said, we will release control. We will let you choose your own data center available hardware, but we have to make sure that it has to be approved by SAP. Why is that? If you remember, the technology behind SAP HANA that is making it extremely powerful. Do you remember that the underlying massive parallel processing and the required hardware that is needed to make your HANA processing powerful? If you decided to use a very low cost, cheap, incapable hardware, and you went back to SAP and said, hey, I built my own SAP HANA system, it's not giving me performance, the performance is really, really bad, then you could go back and complain, right? You can actually file a lawsuit against SAP saying that you promised so much performance in my HANA system, but it's not coming through. So what did SAP do? SAP said, I will let you choose your own hardware, reuse your hardware that you have in your data center, but we have to come and certify that hardware, saying that it is at the approved level to be supporting your SAP HANA system. Does that make sense for everybody? That is what is called TDI approach. Companies using their own data center related hardware and combining it with SAP HANA, making it a much more reasonable product for organization. So what are the advantages real quick? Of course, now Srikanth, you will understand that more flexibility. Would you agree? Second thing is, naturally the cost will come down because now I'm leveraging my own hardware, available hardware. I'm not buying everything as an appliance, right? But what could be the disadvantage? Because it is not bundled, the assembly of everything has to be done by my own organization. The assembly, installation, maintenance, everything, installation, maintenance, everything has to be now done by my own organization. The time taken to install and get it ready is going to be longer. So does that make sense for everybody? What's happening? What's the difference between? So we are still now talking about on-premise solution. That is to bring the asset, the infrastructure into my own data center. But when I bring it into my data center, do I want to bring it as an appliance or do I want to bring it as a TDI approach? So during the earlier discussions you will have in your organization, the company will decide whether should we go for an appliance based opportunity or should I go for a TDI based opportunity? What is the other advantage? Because it is more flexible, you are not restricted like an appliance saying that you can only grow for another 1 terabyte. You have much bigger bandwidth to grow. You can build a system that's probably capable of growing to maybe 10 terabytes or 12 terabytes or things like that. But you could have only started at 1 terabyte right now, but you have the capacity to grow to a larger capacity. Srikanth has a question. Does any of companies has previous systems capability to reuse? Obviously, right? See, let's say for example, your CPU, the core CPUs and all that, those can be used for any application. The CPU that I buy, the storage that I buy, the disk space I buy, right? Those are all that can be reused for any application. Even multi-core. I mean, if your organization has, see, nowadays, multi-core is becoming a must for any applications that you have to support. If you want to get better performance on those systems, they are going for the latest and greatest, right? So they already, the companies will already have the multi-core, motherboards and all that, multi-CPUs and all that will already be in place. Or they might have it at a starting place. So you can start with something that is of your own and you can buy additional things. What I'm saying is you're not restricted to buy everything as a bundled option. Like I mentioned, you can go to a Best Buy as an example, pick and choose what you want and only buy things that you already need. Let's say you already have a keyboard in place. You don't have to go buy a keyboard again, right? You can pick and choose what you want from the outside market and get that and you can build your own system. Does that make sense for everybody? That is the thing that you will have to understand. So when your infrastructure team is talking about this to senior management, you can bring out these points as a highlight. You can say, hey, if you're deciding on-premise as a solution, have you decided on whether we should go for a appliance model or a TDI model? So you can ask all these questions to them and the infrastructure team will help and say, hey, actually we have several servers sitting idle in our infrastructure, in our data center. We have a humongous network. We have the best fiber optics cables that are available. Why don't we leverage them? So by asking those questions, you are helping them reach a decision whether to go for an appliance model or for a TDI approach. That is about the on-premise solution. Now, having understood on-premise, let's understand what is happening nowadays with this on-cloud solution. By a show of yes or no, is everybody clear with on-premise? There is a question from Manoj. In a tailored approach, SAP would provide product support and hardware support from respective vendor. In case of HANA appliance, was SAP responsible for? Very good question, Manoj. So Manoj's question is, if the company bought SAP as an appliance, the software, even though it comes as a bundle, any issues with the software you will directly handle with SAP. Any issues with the hardware, the full responsibility of that hardware solution goes to that vendor. Let's say you bought it from Intel or from HP. They are responsible to answer all the questions. To make it simple, what you will have is you will have a one-point contact with SAP. Because you bought it as a bundle, you will say, SAP, we are having an issue with the product. They will ask whether, they will identify whether it is a software related or a hardware related. Then, if it is hardware related, they would reach out to the vendor, or they would ask you to reach out to the vendor, and you would get those problems solved. But if you went with a tailored approach, Manoj, what's going to happen? Your individual pieces, your server could be managed by a separate third-party vendor. Your CPUs could be managed by a separate third-party vendor. So now, if there is an issue that arises, you have to first identify whether it is a software related problem or a hardware related. If it's software, definitely SAP, because licensing, software license is maintained by SAP, so they will help you. If it is a hardware related, you have to now go further deep dive and understand where is the issue. If it is a server issue, you have to go to the respective vendor and things like that. So those are the complexities, right? Though you get the flexibility with the tailored approach, when a problem arises, it's going to take some time in deciding who is responsible to fix the problem. Did I help answer your question, Manoj? Did that make sense? Okay, cool. Very good question. So now talk about on-cloud solution. So when it comes to cloud solution, the names that we have heard in the market, right? Typical big players, Google Cloud, Amazon Web Services, Microsoft Azure. These are some of the prominent names that we have heard. There are many more other companies, but just to give you an idea, right? Of course, Munib is saying SAP HANA Enterprise Cloud, heck, right? But yeah, so there are so many other products, absolutely. But some of the prominent names in the market, when you hear the word cloud, these are some of the names that are very commonly used in the market. So let's understand what it means, right? Any cloud offering. First, let's understand what it means. All it simply means is, if your company is called ABC and you are headquartered in, let's say, Houston, Texas, and you are no longer interested in maintaining your own data center building. You don't want to maintain your data center building. You want to rent from somebody. Some company is maintaining all the servers, all the CPUs, all the network. You want to go just pay rent and use their infrastructure. You don't want to buy their you don't want to own your own assets, or you don't want to own your own building. You want to go to somebody who already has the building, who already has the servers in place, the hardware in place, all these information are available. You just want to subscribe. You want to go get a rental from them. That is what essentially is called cloud offering. So people who are not familiar with cloud, doesn't mean that it is really existing in the cloud, right? That's not the terminology. What it simply means is, cloud offering means somebody else is hosting all the infrastructure. They have the assets, everything in place. They have it ready. They will just rent it to you. They will let you do a subscription and start using your infrastructure. Does that make sense for people who are hearing about cloud for the first time? It's as simple as that, right? Somebody else is maintaining the building. and the infrastructure. You are just going and renting the services from them. So think about cloud offering can be broadly categorized into two different ways. There is a public cloud offering and a private cloud offering. Let's understand the difference between these two ways of doing cloud offering, what it means. Let's start with the public cloud offering. All it simply means is, imagine that it's a humongous building, right? Or I'll just try to draw a cloud here. Shrikant has a question. Is it compatible on Azure? Absolutely. SAP license can be supported on any cloud infrastructure. It could be a Google Cloud, it could be an Amazon Web Service or a Microsoft Azure, or SAP itself has their own cloud environment. That's what Munib was referring to. There are two types of cloud offering provided by SAP. One is called SAP HCP, which means HANA Cloud Platform. This is an offering like your Amazon Web Services, and they also have something called as a HEC, which is HANA Enterprise Cloud. I'll explain the difference between the two different options, right? But let's first, I'll give you perspective of what a public cloud and a private cloud is, the advantages and disadvantages. So when you, as a company, decide that you want to go into a cloud offering, you should know what's the difference between a public cloud and a private cloud. A public cloud is nothing but, you either think of it as a cloud diagram like this, or you think of it as a building, a big building. So many companies can go rent space within that building. They can say, let's say for example, your company is called A. I take a section of your cloud or your building and I rent this particular section. There could be the infrastructure maintained here. I could have another partition in this big building where company B is hiring infrastructure, renting infrastructure. There could be so many such different companies sharing the same building and renting infrastructure for their own requirement. Now, this is called public. Public means that infrastructure, that cloud is available for anybody who wants to rent it. Okay, that is called public offering. What could be the advantage of using for a company? If I'm a company and I decide that I want to go into cloud solution, I want to go rent infrastructure from a cloud or some different vendor, right? What is the advantage of going to a cloud, public cloud? It is cost effective because so many companies are sharing that same. Exactly, Parni is absolutely right. It is cheaper solution for me. Would everybody agree? That is the only advantage a public cloud offering has to offer for us. But what are some of the disadvantages that you can think of? Could security be a concern? Perfect. It makes logical, right? If you think about it logically, security is a bigger concern. If I'm a banking institution and I go rent a public cloud, though I'm separated from another organization renting the place, there is a lot of possibility for breach of security. Would everybody agree? With cheaper cost comes less protection, right? So security becomes a bigger problem. And the other bigger problem I have with public cloud offering is because it is a public infrastructure. Let's say this organization is maintaining HANA database in all these places. Let's assume that these are all HANA databases, right? All these databases are owned by this infrastructure company, let's say Amazon or Microsoft. They own this database. They bought this database and they are renting these database to us. SAP comes to Amazon Web Services or to Microsoft and says, hey, I have recently upgraded the HANA system. you have to go and upgrade your HANA patches to stay in the latest and greatest. So what will happen? Do you think Amazon Web Services or Microsoft Azure will go to each of the renters and say, hey, I have got a new patch that needs to be applied to the HANA system. Can you please stop working on whatever projects you're working? I want to go and upgrade the underlying hardware. They would not do that. In a public cloud offering, they have already, when you sign a contract, they will say they have a quarterly or a periodic maintenance that they will do. They will not even ask for your permission. They will give you a stipulated time. They'll say every third week of the month or every fourth week of the month, we will go and upgrade the infrastructure to the latest and greatest without your permission. So what happens? Let's say you started a project and you were in a support pack, let's say 01. You were in a patch level 1. Your testing is all going halfway through. They didn't even ask you, they went to support pack 2. Functionality could have changed, and whatever development you did, you will have to go start all over testing it again. So what I'm trying to say here is, in a public cloud offering, you have no control over upgrades and maintenance. This is a big deal for organizations, right? Does it help understand how it is going to help you in a real world project? Why are we understanding this concept is, when you're having this initial discussion with your senior management, people would have probably at the senior management level, they might not understand the nitty-gritties of the technical details, right? They would have heard somebody saying that another CIO would have talked about cloud offering. They would have said, hey, I'm really happy with cloud, my company going into cloud. So your senior management would say, I'm also going to go into the cloud option. But they wouldn't know all these nitty-gritties. What could be the potential impact? So by you understanding all this, you can explain, okay, let's go into cloud, but do you think you're looking at public or private cloud offering? When you think about public, these are the advantages you have, but these are the disadvantages you're going to face. Are you okay with that? So you're able to provide those additional information to your team. Does it make sense for everybody what public cloud has to offer, the advantages and disadvantages? Then, if everybody is clear, then we move on to the private cloud offering. It's nothing but, think about it similarly as the same cloud you have. Still, the infrastructure or your building is partitioned so that many companies can go and rent their individual functionalities. But what's going to happen? The division between each company is going to be extra tight. The firewall is going to be put in place. They are going to incorporate extra security to make sure that no information crosses from one side to the other. So typically what's going to happen, they are going to put extra effort in maintaining the privacy of one company from the other. What's going to be the biggest disadvantage? Here, my cost is going to increase. Would everybody agree? Because I am putting a lot of, I'm asking the infrastructure company, Amazon Web Service or Microsoft Azure to privately secure my infrastructure. They are going to do that, but it's going to come at a cost. What are the advantages? Naturally, the security is going to be a little more better. Is it going to be as good as owning your own infrastructure like an on-premise solution? Never, right? It's never going to be, because you are hoping some company is doing the security for you. It's not like your own maintaining your own security, but in comparison to your public cloud offering, it is going to be much better. What are the other advantages we have? Because I have complete say over my own infrastructure and it is privately secure, Parni is absolutely right. I decide when the upgrade and maintenance happens. The company which is doing the subscription controls the upgrade. So even though another company went and upgraded the HANA database, you could say, I'm in the middle of my project. You cannot do any upgrade until I'm done with that project. So you control the upgrade and maintenance capability in the organization. Does that make sense for everybody? By a show of yes or no, please. So when it comes to cloud offering, those are the two different options. But now, when you talk about cloud in a day-to-day functionality, right? You're not going to be talking about, hey, I'm going with a public cloud offering or a private cloud offering. There are some common terminologies that are used in the organization to decide on what kind of subscription. How do you want to do the rental? How do you want to rent the cloud offering that is available in the market? So there are some few terminologies that are commonly used. I will quickly give you an information about what that is. So let me broadly categorize, put a matrix together. I'll show you what kind of information I'm talking about. Hardware, software, and then I will call it as maintenance. When we talk about hardware, what are the things that we always focus within a hardware? Network, storage. I'll put the CPU and server and all that in the storage, and then database. When it comes to software, what are the things? Software license and the different applications that I want to buy, right? It could be SAP HANA license. I could buy SAP BW license. I can SAP ERP license, things like that. And then when it comes to maintenance, I have to maintain the hardware and I have to maintain the software component. So keeping these as my KPIs, let's understand what are the different types of offerings that we have when it comes to cloud. Let's call this as cloud offering. If your company is an extremely lazy company, just to give you, just to put things in perspective, right? You don't want to lift a finger. You just want to get started with everything. You don't want to do any of the hard work. You basically want a plug and play. You are not worried about doing any installation. You don't want to do any licensing work. You don't want to do any kind of maintenance. What is the most best type of cloud offering that's available? It's called software as a service. You would have heard this name called SaaS. Are people familiar with this terminology? There is something called as a cloud offering called software as a service. If you go to a product like Amazon Web Services, or if you go to a Microsoft Azure and you say, I want to rent your cloud offering as a software as a service, what it means is they will provide you the network. They will provide you the storage. They will provide you the database. They will take care of the license. They will take care of all the applications you need. They will maintain the hardware. They will maintain the software. All you have to do is just go use it. That is what is called software as a service. It's the most easier approach to cloud offering. Obviously, it's going to be highly priced, right? Because everything is done by that company. What could be an example of something that you're using on a day-to-day basis? I'm sure everybody is using something called as WebEx, right? Is everybody familiar with WebEx meeting? In order to do WebEx meeting on a daily basis, are you maintaining the network for it? Are you maintaining the storage capacity for it, the database, the license, the application, or the hardware maintenance or software maintenance? No. You just open browser and say webex.com, you put your username, password, you're logged in, you get connected and you start talking to people. That is an example for a software as a service. Does that make sense for everybody? I'm just putting things in perspective, right? Once you understood what a private cloud and a public cloud offering is, what kind of service are you expecting? That's what we are talking about. You can go for a software as a service. That's the highest level of service you can get from an organization. If you do not want everything, then you can go for a next lower level type of capability that is called managed cloud as a service. It's MCAS. Basically, MCAS gives you everything except your license. It will do everything for you. All you have to do is you have to just bring your own license along. You have to talk to SAP HANA and get the license for SAP HANA. But once you have got the license, they will give you the network, they will give you the storage, they will give you the database, they will give you the applications, they will give you the maintenance of hardware and software. You just need to make sure whatever applications you decide, you have to go buy the license for that alone. Amazon Web Service is an example where you can get this. This is more of a exclusive type of service they provide. It's not as great as the software as a service, but it's very close to that. Only the licensing part is going to differ. Another example here would be SAP HANA Enterprise Cloud. HANA Enterprise Cloud is a managed cloud as a service. It will give you everything, just that you have to go get the license alone. Everything else will be taken care by the company. Let's say you don't want to go this level. Srikanth has a question. Named and concurrent we need to buy in SaaS also. Am I right? Correct. I mean, there are certain things that you will have to get, Srikanth. What I'm simplifying it to explain that software as a service is once you have subscription done, everything, your software, your hardware, everything is given to you automatically. That's what I'm trying to say. It's the most easiest way of getting access to something, right? If you do not want that level of ease, you want to do something on your own, then you go for this is lesser expensive than SaaS product. That's what we are trying to say. If you do not want, but this is definitely expensive, right? It is for sure expensive, but it's less expensive when compared to software as a service. If you do not want this, so Srikanth is asking, how is it going to be different, right? Here you have to go through the negotiation of talking with SAP and getting the license agreement and deciding on how many users you want, how much capacity you want. Depending on the capacity and all that, you will have your licensing cost will differ. Here you have to buy licenses, but your licenses are only for the usage. Okay, you do not own the licenses here. In this case, you're just getting, you're saying that my company is going to use 50 people can potentially use the WebEx services. So your services, you're renting the license for 50 people. You don't own a piece of the software. Okay. WebEx, you're just buying the services to use it for 50 people. In the case of the second managed cloud, you own the license. Tomorrow you decide that I don't want to go with Amazon Web Services. I'm moving to Microsoft Azure. You still have the license with you. You can carry your license to another cloud company and start your services. Okay, does that make sense, Srikanth? Did I answer it? Okay, now if you did not want that much, then you can go to something called as a platform as a service. It's called PaaS. PaaS is also very similar. Certain things that, of course, everybody will give you the hardware component. Naturally, the software component will not be given in your platform as a service. But once you have got the software license and the applications that you want, they will provide the hardware maintenance. You still have to get the software maintenance either done by yourself, or you can hire some additional vendors to perform the software license. Typically, you will go with SAP to help you with the maintenance of your software. So that is the next level of capability that you can offer. Example here, again, Amazon Web Services, Microsoft Azure, or an SAP HANA Cloud Platform. These are examples of platform as a service. They will give you the hardware capability. At least in the managed cloud, they could give you the applications once you bring the license. But here you have to bring the license and you have to tell me which application you want to run. You have to bring the application software to me and I will install it for you. The hardware maintenance will be done by the cloud company, but the software maintenance will not be done by that. Final option. So this is cheaper than, economical than the managed cloud service, but it's still expensive. The last prominent option is infrastructure as a service, IaaS. They will give you hardware support, no software support, nor no maintenance support. All they will do is just give you the infrastructure. Everything else is additional charge that you will have to go for. Again, you can go with Amazon Web Services, Google Cloud, or Microsoft Azure. They can either give you infrastructure service, they can give you platform service, or they can give you managed cloud as a service. So the reason why I'm giving you this is, obviously we are not authority on cloud offering, right? But when you have that initial discussion with your infrastructure team and your senior management, not only you're establishing your credibility, it's an opportunity for you to show off the knowledge you have, right? You can say when they are trying to decide whether to go for a cloud offering or for a on-premise solution, you say, let's take a step further and understand what are your requirements. What are the things that you're looking for? Are you trying to reduce the cost? Are you trying to focus on security? Are you trying to be flexible? You want to ask all these questions, help them walk through the different options you have and help them decide which option is better for them. Did that make sense for everybody by a show of yes or no, please? I know you're not going to use the skill on a day-to-day basis, but I'm hoping that it gives you a perspective. I'm hoping you have a better understanding of on-premise and cloud before we started the class. Does that make sense? The final option, we have said, when it comes to deployment strategy, we said you have on-premise, you have cloud, and third option is hybrid. Hybrid is not a different solution. All I'm saying is companies will decide that, I know the future roadmap of every organization is they want to reduce the cost, right? They don't want to start maintaining their own data center. They want to look at some kind of cloud offering. But people are still not convinced that, say, cloud is the best way to go because they're still worried about security concerns and all that, right? So what happens when you talk about your system? Let's say your company is buying SAP HANA. Typically what happens is your company will at least have a SAP HANA excuse me, development system. They'll have an SAP HANA QA or training system, and at least bare minimum, they will have a HANA production system. This is called a landscape. At least an organization, when they buy SAP HANA, this is where developers will go develop the objects. Once they have developed it, they'll move it to the QA system. Here is where, so this is where development happens. This is where the users will come and test whatever you have developed. And if everything looks good, they will send it to the production system. That's where it becomes a live product. So organizations, what they will do is, because this is the most critical system, your production system is the most critical and sensitive system. Typical approach has been that they will keep the production system in on-premise system. That is, the software, the hardware components that are required to run your production system, they will be housed in your own building. Why is it called a hybrid approach? They'll probably say, maybe my development system and QA system need not be extremely sensitive. I can try using a cloud option for my development system and my QA system. So thereby I'm getting my feet wet in the cloud solution, but I'm going to keep my production system in the on-premise. When you go for a combination like this, it is referred to as a hybrid solution. Is everybody clear with the deployment strategy? What we are trying to do here? Again, it is a foundation information. It is for you to have soft skills to know what is happening when people are talking about deployment strategy. So the idea of deployment strategy is to help you determine where HANA system is going to reside. Does it make sense for everybody? That's the question that we have answered. Now, the next question we have is deployment option. Srikanth has a question. Will it be fast to replicate when dev is in cloud and production on premise? There are challenges, right? See, first, of course, there will be challenges here, right, Srikanth? I'll explain what those challenges are. Now, you have been doing development in a cloud environment. You have been testing in your QA system also in cloud environment. These are not your own system. They could be at a specific support level. They could be at a separate level of information. But your production system could be in a on-premise system, right? So you could technically be doing an apples to orange comparison. There could be some differences between what you tested and what you developed in these systems and what is happening in your production system. You have to pay extra attention to maintain all these systems in the same level. That's going to be one challenge. Your question about replicating information. Typically, network communication between cloud and on-premise solution is a typical challenge. See, when you have your development system also sitting in your building and your production system also sitting in the same building, the network connectivity between the two systems is going to be lightning speed. There won't be any lag when you're sending communication between the two systems. But now this cloud offering that you have for your QA could be sitting in India. Your production system could be sitting in Houston, Texas. The transmission time taken for sending data communication back and forth could be having a data lag. So the latency could become an issue. So those are some of the challenges you will have. So those are the things that you will have to consider before deciding whether you want to go for a hybrid option. The most prominent option that I have seen in the market, what is very prominent in the market is, in addition to your development, QA and production landscape, we also have another system called as Sandbox. People who are familiar with SAP product, you will have another system. This is more like a proof of concept system. You want to play around with the latest and greatest and see what's happening. So what organizations will do is, right now, the most prominent approach is all these three will be on premise. To play around with the latest and greatest, they will go and buy a cloud offering. For doing proof of concept, you can even go for a public cloud offering, right? You don't care if they go and do constant upgrade on the system or maintenance, or if they even do, even if there's less security on the system, I'm not going to put any sensitive data. Does it make sense, Srikanth? That's what typically I have been seeing in the market. People are readily going and doing their sandbox system on cloud. They're trying to slowly venture into bringing in their development system onto cloud also. But you are faced with a challenge that you could potentially be doing an apples to orange comparison if your development and your QA system is on cloud and your production system is on the on-premise system. You will have to maybe do extra additional effort to make sure they're always in sync. So Srikanth is asking, data in the golden client should always be mirrored with production system, right? Correct. So when Srikanth is referring to golden client, he's referring to the sandbox. Typically what happens is, if you want to do any isolated proof of concept testing and all that, you will take the data copy from your production system and put it into your sandbox. That's like a pristine system. You keep it very pure. But what will also happen is, Srikanth, if you have sensitive data, you will mask it. Data will never be, the production data will not be, it will always be encrypted in your golden client. They'll typically keep it that way. They will never give sensitive information in the sandbox system. What I'm saying is, if your organization is using this as a golden client and they want to keep the data as is without encryption, then you would not go for a public cloud offering. Then in that case, public cloud offering does not make sense. Then you will go for a private cloud offering where your data is secured when compared to your public cloud offering. Make sense? All right. That being said, let's now go into a different topic. Let's talk about deployment option. Deployment strategy talked about where to reside your SAP HANA system. So the moment I say SAP HANA system, it contains, I want you to, going forward, when I say, now you all understand that the moment I say hardware, what are the three things that should come to your mind? Your server and CPU capacity, the database, the network. These three things should come into your play the moment I say hardware. The moment I say a HANA system, going forward, the moment I say HANA system, imagine that it comprises of three components, okay? The software component, or this is where the application is going to be sitting. An operating system layer. You will need an operating system to support this HANA system, right? And then you will need your hardware. So hardware further is broken down into all these pieces. So going forward, the moment I say I'm talking about a HANA system, think that it has three different pieces. Software layer is nothing but this HANA system is running what application? Are you supporting an SAP ERP system software? Is your HANA system supporting a BW system? Is it supporting a CRM system? That's what this application layer is talking about. The software that is being supported by your HANA system. Operating system, there is only currently, you can only, so what are the common operating systems that we have heard of? Everybody has heard of Unix. You have heard of Microsoft Windows operating system. And there is something called as Linux operating system. For your company to run HANA, they can only at this point use Linux operating system. There are talks happening to leverage Microsoft for supporting HANA systems, but at this point, the only approved operating system on which HANA can run is Linux. Even within Linux, there are two flavors of Linux that can be used. There is something called as a SUSE Linux, a version of Linux called SUSE Linux, or Red Hat Linux. These are the only two flavors of Linux your HANA can be supported on. Okay, very important certification question. They'll ask you what are the approved operating systems on which SAP HANA can run. It can only be Linux flavor. Within Linux, it could be, people say SUSE or SUSE, it doesn't matter. And then Red Hat. These are the approved. And then of course, you know the hardware component of it. Does it make sense? Going forward, the moment I say HANA system, imagine that these three components come into play. What are we talking about here in deployment option is, you have this three components. You have the operating system, you have the hardware, You have the software layer. What applications are supported by your HANA system? That's the question you're answering with the deployment option. The question is, when you deploy your HANA system, is it only capable of supporting one application like SAP ERP or BW or CRM or SRM example, or can it support multiple applications at the same time? One system, so one box like this, can it only support one software or can it support multiple applications? That's the question that we are trying to answer here. So when it comes to deployment options, there are 4 different prominent options that are available. Let's take a quick look at all the 4 options and see what are the advantages and disadvantages. In the early 2010-2011 time period, the only deployment option that was available was called HANA as a standalone system. It didn't have actually a naming convention. All it meant was you bought this HANA system. So this HANA system, sorry, here's some background noise. Oops. Okay, thank you. So there is, I'll put this as the operating system. The hardware layer contains the network, database. So I'm going to put the database a little bit different so that storage, and think that there is this HANA database and it is supporting one layer, one application. It could be ERP or BW. Only one application could be supported by this database, by this network, by this operating system layer. Okay. So what are the advantages of doing installations like this? The application gets complete priority. Would everybody agree? That's the only application that is running on this HANA system. So I get to fully use this HANA database. I get to fully use this network and storage capacity. I utilize the operating system's capability fully only for this one application. So better utilization of my resources. Would everybody agree with the way I explain it, right? Because that application gets full functionality of my hardware. My full hardware is dedicated for that particular application. What could be the disadvantage? Anybody? My company, let's say my company has ERP system and BW system, both needs to be supported by HANA. What could be the potential disadvantage? Cost. Would everybody agree? ERP has to run on a separate HANA system. I have to go buy another system which is going to support my HANA BW system. So exactly, upgrade has to be done separately for these systems. Maintenance has to be done separately for these systems. Especially cost is going to be a significant deal here. So naturally, organizations started complaining, right? They said, if you give me only an option called standalone HANA systems that I can buy, if I have 10 SAP applications, I have to go and buy 10 different systems to support my application because each one of them have to run on their own HANA system. So SAP did some more research and they said, after all these complaints, I'm going to now create one more option for you. And that option is called MCOD. It stands for multiple components on one database. MCOD. MCOD. Let's understand what is this MCOD solution. So in order, when clients complain saying that you should let us run multiple applications on my HANA system, they came up with this solution. Here, what they said, you are still dealing with one system, one HANA system, which means you have one operating system, one network and storage capacity. You have one database, one HANA database, but you can run multiple applications. ERP, let's example, ERP and BW. You will create a partition with this in this HANA database. This partition is called a schema, okay? You might not understand it now, but just go with me. You will create a separate partition, schema 1 and schema 2. This schema will be supporting your ERP application. This schema will support your BW application. Okay. So one database, that's the name, one database supporting multiple components. The components in this case is nothing but your different application. So they looked at the challenges they had with the standalone system and they came up with a better solution at that time where you can start running multiple applications, but within the same HANA system supported by one database. What are the advantages? Obvious advantage is cost effective. Everybody agrees? It's definitely a better product for me than buying 10 different HANA systems, right? Now I can hopefully run multiple applications on the same system. But what are the disadvantages that you are going to have here? Resource contention. What do I mean by resource contention? The same HANA database is now shared by ERP and BW. The same network and storage capacity is being shared by two applications, the same operating system. Whatever bandwidth I have in these hardware are being shared by my two applications. Out of these two applications, which takes higher precedence in your organization? Will ERP need more resources or your BW system will need more resources? This is your system of record, your OLTP system. OLTP always takes precedence. That's where your transaction is coming and sitting inside. So you have no control over your resource contention. Whichever asks for resources, that will get the first priority. So the disadvantage is resource contention. Second thing is, because it is one database, you cannot say, I want to bring exactly. Manoj is absolutely right. That's exactly what's the point I was going to say, Manoj. Because both my applications are being supported by one HANA system, if I want to bring down the HANA system, I bring down both the applications. If I do a maintenance on my HANA database, ERP will not be running, BW will not be running until I bring back the HANA system. So there is no isolated maintenance. I cannot decide I want to only maintain the ERP application. I want to do some maintenance downtime on that. If you decide for a downtime, entire application supported by this database needs to be brought down. Next thing is, so that is maintenance, right? Is an issue. The third thing is, because I have one underlying database. See, in my organization, I can have probably 100 users who are specifically ERP users. I can create user IDs for these 100 users. And there could be another 1,000 users who are exclusively BW report users. If they were running as two different systems, I can maintain the 100 users here, and in the other system, I can use the 1,000 users here. But because it is all under the same umbrella of one database, I have to give all these 1,100 users access to both ERP and BW. I cannot isolate user management between applications. Does it make sense? If I give somebody access, I'm giving them access to both ERP and the BW system. Okay. User management becomes difficult. So when SAP came and gave this information, company started appreciating it. It is better than the standalone solution. But now they said it's causing resource contention. I cannot do separate maintenance. I cannot do separate user management. Give me something better than this. SAP said, okay, we will give you the third option called MCOS. Multiple components on one system. MCOS. It's a slight variation to your MCOD. The same system, you have your operating system, you have your network and storage. The difference is within the same system, they are going to give you multiple HANA database. HANA database 1, HANA database 2. So they are giving you individual HANA database all within one system. Okay, this is still one system, but they are giving you multiple databases. So what happens? Your ERP application can run exclusively on one database. Your BW application can run exclusively on another database. With this, what is the advantage? You're still not completely avoiding your resource contention. At the end of the day, you're still using the same network storage and operating system. The leeway you get, or the better effect you get here, is you now have individual HANA databases. So that reduces the resource contention you are using in the system. So less resource contention. I'm not saying totally gone, but less resource contention, controlled maintenance. Would everybody agree? Because I have exclusive HANA databases associated with my application, if I want to take a downtime, I can exclusively do a downtime on this while this system is still up and running, and vice versa. User management can be isolated to the individual systems. Does that make sense for everybody? Going from an MCOD to an MCOS, I am now able to do better resource management and better user management and controlled maintenance in the system. All right, that is the disadvantage, is still that it is going to be a shared resources, right? So that disadvantage is there, and the cost is now increasing because now I'm maintaining two HANA database inside the system. Not duplicate information, right, Parni? Because this is isolated HANA, this is isolated HANA within the system. So there is no sharing of information that's happening between. Oh, when you say duplicate information, if at all I want to push data from here to here, then I'm duplicating the data. I agree with you. But purely from an infrastructure perspective, not going into the data level, right? I'm helping reduce the resource contention. I'm helping improve the controlling and maintenance of the system. I'm also helping maintain separate users. I can individually bring down and bring up the systems without touching the other system. Then SAP came up with one more option called as MDC. MDC stands for multi-tenant database container. It's a slight variation to your MCOS system. It is still one system. It's using operating system, network and storage. It has multiple HANA databases, HANA 1, HANA 2, HANA 3, and so on and so forth. And then they can support multiple applications like ERP, BW, and let's say CRM example. One thing I forgot to mention here is, see, though this became an advantage, what if I wanted to bring down both my ERP application and BW application? There is a major release that happened in HANA. I have to go upgrade all my HANA systems in one shot. I have to now do it individually, right? Because they are isolated systems. One of the disadvantages, though there are many advantages with the MCOS system, what is one disadvantage? The disadvantage is that I won't be able to do mass upgrades and control and maintenance on this system. So keeping that in mind, SAP came up with this fourth option. In the fourth option, what they call this is they have a master database, master HANA database, and each of these database act like a slave or a tenant. So what happens? You get the flexibility of your MCOS system. If you want to individually do maintenance on your ERP, you can isolate this and do it. You can individually maintain user management for this. Similarly, you can do individual maintenance on each of the system. But at some point, you want to do a collective maintenance on your entire HANA database. The master can control all the slave or the tenants at the same time. The master has the capacity to say, do individually maintain the systems, or in one shot completely control all the systems and do the maintenance. So when your organization buys SAP HANA 2.0 product, by default, the option suggested by SAP is go for a MDC option. That being said, your company doesn't have to decide on this. Out of the four options, the most prominent and most implementations are happening currently on MCOS system. Okay, so that's what I wanted to explain. So these are the four different options. Again, as a HANA consultant, you will not be expected to know these level of detail. This is a pure SAP administration team's activity along with infrastructure. But if you are fortunate enough to be part of that discussion, you can give in your comments. You can say, hey, are you deciding on multi-tenant database or MCOS system? You can say, hey, MCOS definitely has its own disadvantages. If you're choosing between MDC and MCOS, MDC gives you the better advantage of controlling all your databases in one shot, but that capability is not available in your MCOS system. Okay, so that's what I wanted to explain for today. Is everybody comfortable? I know by no way you can become an expert in deployment option in one session. That is a complete infrastructure discussion, right? No integrity, but the details of it. But idea here is I want you to be able to, at a high level, appreciate what deployment option and deployment strategy is all about. So by a show of yes or no, could everybody tell me if you're clear with the concept? Please, okay, Samshul, thank you. Perfect. So we'll stop here today. Actually, I have to quickly go somewhere. Somebody is waiting for me. So tomorrow is going to be a lot of information. We are going to go into the look and feel of the system. We are going to look at something called as HANA Studio. We are going to look at something called as the Web IDE. And we are going to cover the technical architecture of SAP HANA. With tomorrow's session, we would have completed all the topics that we wanted to cover for foundation. And if time permits tomorrow will be a longer session. We will also start talking about data provisioning. Okay, so that's what we will be covering tomorrow. Tomorrow will be a longer session and a very important session because technical architecture is extremely important for you to understand and appreciate. All right. Thanks, everybody. Have a great day.